can that come from, does it need to be Fedora first? Can it just land there first?
So
Without touching Fedora ever, or?
the question is, for Synergy, are we requiring the packages are landing in Fedora before they come to Synergy? The answer right now is no. One of the things that we are talking about is what the structure of that looks like how we decide what goes to Synergy and what we submit to Apple, or what we recommend gets submitted to Apple, and what that pipeline looks like. Because obviously we've got people that are super invested in Fedora, so like having those conversations internally that's also happening. Easiest topic every day. All right, nailed it. So anybody that has, if you have questions that you didn't get answered today, or you come up with questions, like I said, you can find me on the internet. You can also find me at the table over there. And if you come over to the table, there's a QR code you can scan to sign up for a little coupon at our swag shop, because I don't carry t-shirts anymore. So if you want a t-shirt, come give me your email address and I'll send it to you. We don't have a marketing machine, so your email address will get one email from me, and it'll come directly from me, and you'll get it sometime next week. Go ahead.
Is it too early to talk about OpenELA?
No.
How's that all gonna work?
That's better talk, right?
Whole new talk.
Yeah, that's how much time you got?
Yeah,
So the question for the recording is, OpenELA, how's that all gonna work?
yes.
So I think it's going to be very interesting to see what OpenELA brings to the table. Like, the thing that has been consistently said, and Joe said it yesterday, is we have been beholden to Red Hat for a very long time. And it was good. And now it's not doing what we want it to be doing.
Right.
And that, in open source, always means more people at the table. I think long-term, I am excited to see what kind of value they can bring. We'll see how it plays out. Yeah, does that answer your question? How's that open work?
Yeah, I mean, I was thinking more of like the how, like what's its function going to be in your ecosystem, and
Like I said, that's gonna be the interesting part, right? Because, so we're not involved, almost not involved in OpenELA at all.
Okay.
And if you look at who, like, we weren't approached about it, and it honestly makes sense to me, because if you look at who's there, it is corporate entities
Right.
that came together, created an organization, allowing them to collaborate on something that they will use for their commercial products. Like, it doesn't make sense for me to be there. It doesn't make sense for me to even consider it there, because they're not, you know what I mean? So from that perspective, I'm excited to see more players. I'm excited to see more contributors. I think if it goes the way that they're talking about it right now, then it's gonna be really good. I think it'll improve the ecosystem immensely. That's gonna be the thing. Yeah. Anybody else? Man, I'm fucking magic today. Great. Right, exactly.
I just showed up on my yeah, I'm like, man, I was rush yeah, I think the price is usually then,
Does this look like it's close enough to my face, you think?
Yeah.
Do they usually go higher or lower?
Yeah, no, but that's fine.
Is this where I turn it on?
Yeah. Yeah, but it doesn't look like it's on because it has the LED on it. Oh, yeah. It's better.
That should work. Let's see. Oh, what's it being?
Yeah. Fully expecting this to be a sorrow.
What's that?
Fully expecting this to be a sorrow. And, hey, that.
sit there, go for it.
Is this amplified or just going into a recording?
This is going into a recording.
So it's not going to sound amplified because it doesn't sound
No.
like it's on right now.
Oh, no. That
This
mic
is literally
should
just
be,
recording.
Amplified on over that
Oh, okay.
speaker.
Is it amplified now? Can you hear me talking now?
No.
So,
We
that's
seem
my
to get
question.
that on. Make sure that you are.
It says it's on.
Okay. Maybe mute.
Test. 1, 2. Hello. Test. No, it's on yellow. Test. If I speak
Right into it. Oh, hello.
There we go. I need to be a lot closer to my face then. That answers the question. All right, if I speak in a normal volume, and I have it here, is that amplified a little bit? Yeah, can everybody hear me in the back? All right. We ready to begin? All right, then. Howdy. Hi. Good. When I first moved to Texas 15 years ago, the second thing I learned was the way to bring a meeting to order is to say this word. So let's try it one more time. Howdy.
Howdy.
Congratulations, you're all honorary Texans. My name is Krista, and I like to play with words. And as I said yesterday, I'm a speaker, not a writer, so here's what I'm reading. But for about 15 years, the last 15 years, I've been a writer, a content creator, a blogger, a copy editor, and a proofreader. That's my wheelhouse. I'm also just a storyteller. Whenever I want to tell a story, I do something. I sit down at my computer with a blank page. I take a breath, like I'm going to do right now, and I write these words. It was a dark and stormy night. I just write it over and over until something comes to me and something else. And then I can write something else. It's an easy phrase to write. It also is often appropriate and helps me get into the story because, as it turns out, many stories do begin with a dark moment when the world becomes off balance and there's just one reason or another that someone has to get out of that situation. So, I forgot to put my next note in here, but a lot of people come at this point and introduce themselves by saying their open source experience in order to draw connections with the people in this room. We're going to do it a little differently because I'm a storyteller, so we're going to do a little storytelling and you're going to participate. So first of all, is there anybody in this room who's left-handed? All right, congratulations. We all have this in common. I am also left-handed. Is there anybody in here whose favorite season is fall? All right, me too, congratulations. We have this in common. Fall is my favorite season. This time, let's see the great debate of chocolate and vanilla. Anybody here like vanilla better? A couple. Anybody in here like chocolate better? All right, I'm a chocolate person, so congratulations to all of you who just raised for chocolate. That's what we have in common. Cats or dogs? Dogs? Cats? I am a cat person. Cats are just better. No, they're not. Cats are jerks. But that's what I like about it because I can leave them alone and then they leave me alone. I have found that dog people make very good friends because they understand and appreciate loyalty. Cats do not. Okay, car or truck? Anybody in here driving? Well, who drives a truck in here? Okay, so I have a few truck people. Does anybody in here drive an electric vehicle?
Hybrid.
Couple? Hybrid counts, whatever. We're all friends here. Is there anyone who drives both a truck that is an electric vehicle? All right, this is what I have that is unique in this room. That is what I have.
Lightning already.
We can talk about it later. I drive a Lightning, and it gives me various degrees of fits and excitement all at the same time. Okay, now, as I said at the beginning, I am from Texas. So I said earlier, it was the second thing I learned about Texas was the howdy thing. The first thing I learned about Texas was this. There are two kinds of Texans. There are the kind that were born there and the kind that got there as quick as they could. Now, do I have any Texans in the room? One. Which kind of Texan are you?
We were in Galveston,
So you're the kind that got there as quick as you could?
yeah, his family was from there, so it was kind of.
You were born there.
No, they weren't in Oklahoma.
Either.
From Texas.
Okay.
We moved down to Texas. I think I probably kind of got there.
Got there. Okay. That's good. I am the kind who got there as quick as they could. Because I'm actually from Ohio. Now, is there anybody in here from Ohio? And I don't care if you were born there or you got there as quick as you could. Everybody counts. Excellent. Lovely. This is something that very many of us have in common. Hopefully you found a little something in common with me today. So now we're going to come back around to my software story. Software development, open source experience, which is that about a year ago is when I started in open source. And so that makes me the kind of software person who got here as quick as I could. Here we are, and today we're going to talk about Rocky Linux, where it started, where it's going, and what's next. So many of you here to hear this. Where it started. Where is a great place to start? I have an idea. It was dark and stormy night. All right, great. It really suits a little bit, don't you think? There was a day when the story starts, and I am pretty sure that somewhere on the planet, on this day, there was a thunderstorm. But even if not, there was. But on December 8th of 2020, there was at least one big thunderbolt on the internet that threw everything out of balance a little bit, or a lot. The enterprise Linux ecosystem was thrown off. So from that first announcement, a team of like-minded people came together to create a new enterprise Linux distribution to fill this gap that was left by the evolution of CentOS to meet the felt needs of the community. Could somebody bring me a cup of water, please? Thank you, my CentOS friend. So the team identified and overcame obstacles along the way and released the first stable release within about 6 months that they entitled Green Obsidian. So that was their first stable release. And I think the date is up here of June 21st. Thanks so much, Sean. The whole point of this distribution was to create something stable for and accessible to the open source community, to account for the millions of servers that needed to just run for years at a time with as little maintenance as possible. That was the driving force from the beginning, was this wanting to create something stable. So we created something called a clone. That's, I think, what CentOS was known as, and that is what the community wanted to continue. It's funny to talk about clones, RHEL clones, having distinctives, but we were asked several times over those first few years, well, what's the difference between you and whatever other one, what other distribution? A clone is a clone. But a clone is a clone, and if it's made well, it's going to work exactly like the original. But why is it so important to be like the original? Because that's what the community wants and needs. They need their clone system to work exactly the way their production systems work, and they need something that has easy transition from their what they know, which is the standard of Red Hat. So how does that work, maintaining an exact clone of RHEL? Our developers tend to get a lot of requests for changes or for new features, which gets just generally one of a few responses. The first would be to say, if you want this added functionality to the system, then you can go participate in or create a new special interest group known as SIGs. We have about 24 SIGs that are currently active in the Rocky Linux chat server. Including for HPC, all architecture, cloud, and others. And I'm going to give a special shout out for the SIG VFX, which is the one that works on the movie production version. And I wish them all the best because I want to own the world for visual effects. But sometimes it's to fix a bug in the code. And in that case, what our developers would do is submit a bug request upstream and have it be fixed upstream, either in RHEL or above that, so that it can be fixed up there and then come back down in the next updates. Ideally, that was the idea. But also we have a few, what we find are distinctives in the Rocky Linux community. First of all, there's this Peridot build system that was created pretty close to the beginning. Need a minute there. It's a set of tools, really, for the release engineers to streamline the cloning process. The GitHub repo's description of Peridot is this. It's a cloud-native build and release tools tailored to building, releasing, and maintaining Linux distributions and forks. It's designed to be easily reproducible. This provides added assurance and stability for the community, which is, again, our key primary goal, driving goal, is the stability. By providing the needed information to make it easy to even fork and keep going in the event that Rocky itself should someday be discontinued, if that should ever happen. It's just insurance. With that same commitment to helping the community, we have also worked hard to create a robust documentation server or documentation tree. We know that we're trying to catch up with projects that are 20 and more years older than us. And so that is one of our primary goals. And I think we've done a decent job at it for the fact that it's been 2 or 3 years. We do have a small but dedicated team of documentarians. We have subject matter experts, editors, and translators. All 3 of those are an important part of our team. And we are always looking for more people to contribute to that. I've made it really easy for you, if you're feeling spontaneously inspired right now, that you can check this QR code out and drop into our documentation contribution guide. I know I get so many I know I should contribute to documentation, but, and then there are several reasons. We're trying to take away the reasons and make contributing as easy as possible by helping subject matter people and say, you have the knowledge, we have the editorial skills, let's put it together. So we're trying to just take really contributions in whatever form that you have them available and turn them into something that can become part of the Rocky Linux body of work. And the third thing that we think is really distinctive about us is the actual community. We welcome contributors and we encourage involvement. We travel to events like this. We have online community meetings. And generally, we just want to be here to reassure everyone that we are here for the long haul and that we have the interest of the community at heart. Stability for the community, that's what we want. I would like to make a special note about contributions and contributors. We love all of our users. We have a tight community of contributors. There are a lot of ways to contribute to open source. There's documentation, there's all of the other teams on the projects, including the release engineering and the web design and the security, and I think we have 5 or 8 teams. All of them have room to add you as a contributor. And we always want to make the onboarding experience as smooth as possible so that it is easy to contribute. However, there's an important message that the Rocky team wants to make sure is conveyed. That even if you use our operating system and have never actually gotten involved in the community and have never even contributed anything to the Rocky Linux project, we still value you as part of our community. If you feel like part of our community, you are part of our community, all are welcome. So, from December 2020 to June of 2023, Rocky Linux was born, released, came up to speed, fast enough to be a strong contender in the global marketplace for a stable enterprise Linux operating system. And then the balance was thrown off a little bit again in June. So, how's it going for Rocky Linux? In late June, the Enterprise Linux ecosystem evolved again, as marked by another announcement on the CentOS blog. And that meant that all the downstream distributions, including Rocky Linux, were going to have to adjust the way they acquired source. While the team at Rocky Linux had considered this was an eventual possibility, the timing did require us to make a few adjustments sooner than planned. So let's just get this next slide out of our system. There may have been a moment or two that felt like the "this is fine" meme, with the house burning down around you while you're drinking coffee, saying everything's fine. But we collected ourselves, and pretty quickly we moved on to improvise, adapt, overcome, which is a little bit better and more optimistic and positive approach. So in the short term, we improvised. We dealt with what we had to deal with in the moment. I think there were about 10 outstanding updates. We did whatever we could and used all of our resources to get that up to speed and get those updates launched. And along the way, we tried to develop sustainable processes for how we would repeat it. But at the beginning, it was just to get the job done. And the key was to still keep our promise of releasing Enterprise Linux regularly and to keep it open for the community. One thing I have learned in my brief time in open source is that developers, and very many people are a little bit of developers, even if only some people are the primary developers, but people relish creating a tool for everything. There was so much automation when I came online, so many little tools and utilities that I could use. And this is another example of a time when they had to build a tool to automate their new process. This is a brand new tool that was developed this summer called Mothership. It's kind of evolving. So it is a way to automate the collection and recording of all packages. It also keeps track of the SRPMs that it collects and it verifies them that they're all signed, verified, and authenticated. There's some words I'm still learning. And then the administrators can retract revisions, they can fix debranding patches, and they can retrigger imports for specific versions. I assume you all know what that means better than I do. But basically, this is kind of a way for us to remove the human element a little bit of manually importing things. And instead, it allows us to automate processes as updates happen so that they can happen even if nobody saw it happen yet. It's just happens automatically. So that's what it is. And as they say, they've just barely gotten to the point where they're able to take contributions. So if this is a project that you feel like you would like to be involved in, you can find the Git repo within the Peridot subdirectory of, I think that's in the Rocky Linux server on GitHub. Okay, so that was adapt, and then there's overcome. We are trying to become a more strong member of the Enterprise Linux community. I think there are people in our project that have always been contributing elsewhere upstream. We have always reported bugs upstream. And there's sometimes a perception that maybe we're not doing that. So I guess we're going to get better about calling out what we're doing, even though that has never felt important. But for now, we are working hard to become part and to be seen as part of the upstream RHEL community, because that is ultimately going to help us because it helps the source, and then we can contribute, or then it comes back to us and it benefits us in the long run. Additionally, in August, we had already been planning this, but then it became even more important to do it after that announcement. Several of us attended the Fedora Flock conference and met some people who were part of that, and we began to connect together, try to figure out who we are within the global enterprise Linux marketplace. I think what my perception and my takeaway from that was that we're all just trying to figure out what is our place within, as the balance has shifted within the new landscape, who goes where and does what, and who, what are our roles to play. So we're trying to do that while keeping our eyes open, our options open, but also doing it in a way that promotes harmony as much as we can. So in short, Rocky has passed through this transition and emerged still stable, still stronger than ever. We feel like we've developed processes and expanded our network as we keep in touch with the community, both upstream and down to our community. So this, I think, is a more accurate meme of how we came through the summer. So what's next? The question everybody has. The future in some ways is still unwritten. None of us has a crystal ball all the way down for forever, but much of what happens in the future depends on some choices that we make in this moment and that we have already been making this summer. But our choice right now is to stay the course and to remain 100% compatible, bug for bug, alternative to RHEL. How are we going to do that? I really like this one. We're just going to keep calm and stay on target. So we're going to stay the course by continue developing tools, including Peridot and Mothership, and maybe some more. I heard rumors of other ones that I don't know enough about yet. We're going to continue supporting the growth of our special interest groups. We're going to continue improving and iterating on the documentation because we still want to be the first stop when you're looking for Rocky Linux related documents. And we're going to continue growing our community. Our plan is in place and solid, but things can happen beyond our control. Who knows what our options are going to be in the long term? Since we've developed this new process, there's been this announcement of a new project called Open ELA. This is a new option within the enterprise Linux ecosystem. It has yet to really be created, but as far as what it is intended to be, it's intended to collect the source so that downstream distributions have the option to pull an enterprise Linux source code and create their own distribution from it. Our project, the Rocky Linux project, has not yet formally as a group joined it. Mostly, well, at least because there is not a formal joining process right now. They're literally in a stage of, here's a Slack server, come join the conversation. And there are members of our community who have joined the conversation. I don't know what our long-term prospects are. For now, like I said, we have our plan, but for us and for everybody in the enterprise Linux system, this is an option. It's an assurance of confidence that the source will always be available regardless of the actions of any other entities. So that's how we see it, is that's the value of it. Although we're not currently using it, it does have a good value, and it's great to know that it's out there. So we do plan to continue fostering relationships with our upstream communities. That's both the Open ELA and the Realm sort of, I guess, community, the Fedora and the CentOS. And then there's this. We're still growing in the middle of all of this hubbub. We've finally gotten through the process that was a year and a half in motion, and we're now FIPS certified, which is making Rocky more usable by a wider demographic of companies. That's a great new thing to indicate our stability, which again is our primary goal. And our plan of staying the course looks to at least give us support for version 8 through May of 2029 and version 9 through May of 2032. That is a high priority for the people in the project. And again, the bottom line, our top priority is the stability of the operating system and to keep the trust of the community. It's what drives us every day. So this, ensuring the longevity, stewardship, and innovation of enterprise class open source software that is always freely available. This is the mission of the Rocky Enterprise Software Foundation, which is the host organization of Rocky Linux. This keeps us focused on our goal. It kept us as we adapted to change and caught our balance in this recent season. We kept pointing back to this to say this is how we make our decisions. We may have more changes to make in the future, but we will adapt to them as they come. We're here, we're not going anywhere. So in closing, Rocky Linux is a community-based enterprise Linux operating system with a fast-growing, worldwide footprint, supported by a dedicated team of volunteers. We've overcome various challenges over our nearly 3-year history, but the future looks bright. If you believe in our mission of keeping enterprise-grade operating systems accessible to the wider Linux community, please consider getting involved. We do have plenty of room to grow in every team of our project. Technical software prowess is not required. We do have room for things like graphic designers, web designers, proofreaders, and lots more things. Even getting involved in a special interest group is another way to join the community and grow the project. And that is basically what I brought here to say today. Thank you for your attention. All right, they told me I was going to do a Q&A. Please go easy on me. Yes. Mister, I can't tell if I'm a Texan or not. I'm a little bit Texan.
Where are your security patches coming from today?
That is a question that you're going to have to come talk to us in the atrium about. Okay.
And the question for the
Oh, sorry.
recording
The
was,
question for the recording was, can you say it again so I can repeat it?
Where are the security patches coming from?
Where are the security patches coming from? It's probably not a difficult question,
Probably not, I don't know.
but come talk to us later and I'll have a better answer for you. All right, yes.
So, was there any discussion about going the route that Home Linux has chosen, this ABI compatibility versus one-to-one compatibility?
Was there any question about going the same route that Alma Linux has chosen? Okay,
about compatibility.
with compatibility.
Right.
Sure, we discussed a lot of things, but it was pretty unanimous that we wanted to retain the one-to-one compatibility at all costs, whatever it took, as far as it was physically possible. So that's the route that we're going now, as far as it's physically possible.
Yes, I think I also saw your announcement recently about the keep going this way. But do you have any kind of advantage, like a better relationship with the Red Hat to make it easier, or how do you do that?
You saw the,
So
So
what's
you
your
want-
advantage?
you want to know if we have some advantage. I think we posted about how we're collecting our sources. That's also on one of the news posts that we did back at the beginning. I just was looking at it this morning. It's the one from June 29th. We are collecting our sources pretty much the same way we always have. And we're using Stream and I forget what other sources. Probably somebody can help you with a more solid answer on that as well.
No, it's-
Let's try, yes.
So, I'm glad to hear you're more dedicated to being a one-to-one, more of a clone. Does the organization have concerns about IBM and lawyers and whatever things? Is that?
Do we have
Where's-
concerns about legal litigation by staying fully one-to-one,
Yes,
bug for bug compatible? As I understand it, we feel confident that the license allows us to do what we are doing. So we're just gonna keep going as far as we can keep going.
okay.
No softball questions?
What's your truck's name?
Thank you. Thank you. My truck is named, the question was, what is my truck's name? And my truck is named Mrs. Peacock. That's not any answers of security questions that I have anywhere on the internet. My cat's name. I have too many cats, but the cat I just got to replace my favorite cat that passed earlier this year, the new cat is named Clementine, and I have high hopes that she will be my semi-emotional support animal that I lost literally the same week as the CentOS announcement. So it's been a summer. So you've all been very attentive. I appreciate your time. Beth Lynn.
So I hear that Chris DeBono is part of this, which is amazing. If you don't know him, he was a long time person who was in the Google open source. And before that, some people who will know him from being a character in the Revolution OS, where they were protesting a Microsoft Office to remove the Microsoft tax. Oh goodness, over 20 years ago. So I just wanted to see if you get a sense of what his involvement will be in this project.
So you've heard that Chris DeBona, yes, Chris DeBona is a part of the project as so far as he is a member of the board.
Mhm.
I believe he's considered an independent member of the board, so he's not really part of the Rocky Linux project. As far as I know, he is more of an advisory capacity. And I could be speaking out of turn, but that's my understanding, that we purposely have some people on the board that are from outside the project to give us perspective. And I think he's brought some valuable perspectives. But as I am not a member of the board, I have not been a part of many of those conversations.
One more over here.
Yes, hello.
Not a softball question, I'm sorry.
I'll do my best, and if not, you can meet us in the lobby.
What kind of corporate sponsorship does Rocky Linux have?
So Rocky Linux is supported fully by the Rocky Enterprise Software Foundation. Those are two separate entities. The foundation has supporters and takes care of Rocky and Peridot are current projects, but it is interested to accept projects that are also enterprise open source related. To answer your actual question, we have sponsorship of different kinds from different sources. And those are all listed on I think on the Rocky website. We have sponsors. I know I've met people from various places. Do you have a specific thing you're driving at as far as what kind of sponsors we have? We have, I don't know, there are 15 or 20 different sponsors listed on the page.
Okay. Yeah, that's fair.
Why not now? Maybe it's a little bit of a time delay. That's what it's gotta be, yes,
There it
that's
goes.
all it is. Yes, we are now live.
Okay, cool. I'm gonna record it as well. Video over there, and I'll record the screen here. And then okay. You ready? Can you hear me? Yeah. Okay. I'm sure I've talked to a lot of you guys at the booth this weekend. Coders gonna have our big version 2 launch event Wednesday, September 27th. You can sign up for the online webinar there with that QR code. I also have that out at the booth if you want to sign up out there. It should be pretty cool. I'll be demoing version 2 here as well. So it's available now. It just hasn't gone through all the launch hubbub, I guess. So before OLF, how many of you have heard, or before you spoke to me, how many of you have heard of Code Server? Just a handful. How about Coder in general? Okay, same couple of people. Okay, cool. So, right, we've got a lot of cloud native things going on, right? How many people have their entire, from the time the code is written to the time it's deployed in production, is it cloud native the whole way, right? Some people are, some people aren't. The bigger the company, the less likely it is that they're actually doing their development in a cloud instance. So, I don't know, maybe. Anyway, my name's Tim Quinlan. I'm a senior technical account manager at Coder. I actually just started there a couple months ago. But it's a really cool product. It's a really cool company. We're a startup. We're still Series B right now, but you can see we've got some pretty good investors and some good advisors. Michael Hashimoto from HashiCorp is one of our advisors. He's helping the founders get this thing out, get it to market, and help it to grow. Code Server has been around for a while, and it's pretty popular on GitHub. That's how plus stars. So what is Coder? You've probably heard me say this a million times this weekend at the booth. It's a self-hosted development environment. It's compatible or comparable with things like workspaces and code spaces. However, it's self-hosted. You're not tied into a SaaS or to a cloud provider. You can put it wherever you want. You can run it on a good old-fashioned server. You can run it on Kubernetes. You can run it Docker. If it's a Linux derivative, it'll run, basically. And you're not tied to one IDE. Your developers, all they really need is browser access and a login, and they're ready to go. So there's a lot of problems with software development that we're aiming to solve, right? How many times have you hired a developer and it takes them 3 weeks to get their environment set up, and then now they have to maintain it every time there's an update to a library? You have to make sure all the developers have the latest everything. You can't audit what they're doing if they're doing local development. You don't really have access to their machines. You don't know what patch levels they're running. You don't know exactly what tooling they're running. Giving every developer a big honking laptop can be pretty expensive. And also, depending on what line of work you're in, you may not want your source code out on devices that aren't, in your physical control all the time. Or even on perhaps a contractor's desktop that is, or laptop that's gonna be, a short-term person, and they might have copied their source code out the contract. And it solves the dreaded "it works on my machine" problem, right? Because everybody's gonna have the same patch levels, the same libs, the same everything. You can see we have some pretty good customers already, pretty large. We have some fun ones like Netflix and Discord. We also have a lot of the big financial services companies. And we also work with a lot of government agencies as well. One of the things that the government guys and the finance guys like is you can run Coder anywhere, right? You can run it air gap if you want. It doesn't need to be connected to the internet to work. So the benefits of Coder, day one onboarding, right? You have a contractor or a new hire come in. You don't have to wait for them to get their laptop issued and get it patched up and get everything installed and whatever. You just have to give them access to your source code and access to Coder. And within a few clicks, they can be writing code. The device management overhead greatly reduced. I mentioned before secure data storage. You're in control of your data from the time it's written to the time it gets checked in. All the settings, everything are in your control. You're not beholden to any providers. It's a supported platform engineering solution. Some places, I've talked to a few folks where they say, "Oh, we have something like that we built and maintained ourselves." Okay, well, who supports it? Right? You probably have some SREs dedicated to that, or at least some pretty good developers dedicated to that. With this, you're supported by the Coder community, and you can also buy an enterprise license and get support from from our engineering team. Excuse me. And then the governance and auditing. You're always going to know what revs your developers are using. You can also limit them to not be able to use any local IDs to everything over the web. Once again, there's kind of big agencies like that, some of the financial services places like that as well. And you're giving your developers access to the most powerful instances, right? They're not developing on some, little VM or little container on their laptop or some small cloud instance. Let's say you're using GPUs, something like that, something with some serious power. With Coder, you can give them access to develop right directly on that hardware, the same hardware that you run your product. So we moved pretty quick. Like I said, the release party for 2.0 is in a couple of weeks. We're already up to 2.1.5. We release our Z streams once a week and our Y streams monthly. So when I wrote my slides last week, we were at 2.14, now we're at 2.15. It moves pretty quick. And if there's security patches, we'll do multiple Z streams in a week. And depending on, case-by-case backports for security patches to older versions. This is the Coder architecture. It's pretty straightforward. The control plane and the database are kind of, they can run wherever. And typically, you'll have your control plane up in, some Kubernetes instance somewhere. You can run your database in there as well, or you can connect to an existing Postgres database. And then your workspaces will run sometimes in the same namespaces as your control plane, sometimes not, depends. The demo that I had been shown on the floor was running in Kubernetes, and I had basically the control plane and the data plane running on one set of nodes that were static, and the workspace is running in a scalable set of nodes. So you could fire up 100 workspaces and watch it grow and watch it auto scale and shrink back down. Everything's encapsulated in HTTPS, of course. If you're using a web IDE, it's always going to go through the control plane, and that's going to use dirt or WebSockets depending. It's going to try to always try to use dirt. It's going to fall back to WebSockets still. So whenever you're using a web IDE, you're always going through the control plane. If you're going to use a local IDE, it'll try to graduate its connection to a WireGuard point-to-point connection directly with your container. So it eliminates any sort of round trip back to the control plane, can cut down on latency. And I'll demo some of that stuff later. There's a lot of options. You can have, like I said, you can have your workspaces running in a different namespace or even a different cluster than your control plane, depending on how the trust relations are set up. We have a feature coming out. It's kind of it's still pretty early stages where you could have multiple clusters and you could have one cluster act as a proxy for your control plane. So, for example, if you had developers all around the world, you have your control plane in your database, say in the US, but you had developers over in Europe or wherever, you could spin up a cluster that was local to them, like cloud local, right? They could have a proxy connection back to the control plane. So it would eliminate any of that latency. And that's mainly for the web IDEs and things like that, but it can also help with the instructions too. We talked about this already. The transport security, so local clients, like if you're running VS Code Desktop or our Coder CLI, they're going to try to establish a WireGuard connection using Stun, and if not, they'll fall back to the same. They'll fall back to being proxied to the control plane with dirt and WebSockets, just the same way the in-browser clients are. And you know, of course, everything's TLS. You can terminate TLS like at a load balancer if you're internal, but you know, if you want to do that, you can. So the quick start, I don't know who all has tried it. I know you had mentioned you tried it. This is pretty much, this will get you going. No matter what you do, you're always going to want to have the Coder binary installed on your machine, even if you're planning to run Kubernetes. That way you can, you're not tied to the GUI, right? You can use our CLI, and I'll show you that stuff too. And that's really cool because it's a lot faster, number one, but you can also integrate it into your CI/CD. And when we get into the workflow of how the workspaces are created and pushed out and things like that, you'll see the benefit of that. So that's the end of the talk. And so I'm going to jump straight into the demos. Some of you guys have seen these already at the booth. Some of you guys have seen it for the first time. So the Coder GUI is pretty straightforward. This is the admin interface. If you were a regular user, you wouldn't see users or deployments up here. You would just see workspaces and templates. So we have this idea of workspaces and templates. Templates are really just Terraform, right? It uses Terraform to spin up whether a VM or a container or a pod. Excuse me, I've been talking all weekend. My throat's a little sore. It'll spin up your workspace. It will attach the developer's home directory to it, whether that's a PV or like a Docker volume or a VDK or something like that. And that way they'll always have their home directory, no matter how many times they spin it up or spin it down. So basically the root file system of the workspace is ephemeral, right? So if they go in and do something silly like untar some bizarre version of GCC or something, I don't know, right? Into user bin, that disappears whenever they restart their workspace. And also, if they host something up, they can just simply restart their workspace and start fresh. So, like I said, the demo that I'm showing here right now it's from the quick start, from the curl command that I have out on the poster and I mentioned earlier in the slides. All that does is that installs the binary on our machine, and I started up Coder server. You can see it running here. You see a bunch of Terraform stuff going. and you can see the coder CLI. If you just run coder and then list, it'll show you all your workspaces that are there, same as if you were in the GUI, you can see your workspaces there. So what the user is going to see, say you're going to give them a template or just create a workspace for them. They're going to come in. This is super basic. They'll see this. You can put these stats. That's a kind of a new feature. It's pretty cool. You can see, they can see how busy their instance is and things like that. But basically, they're going to have a couple of different options here. They can jump directly onto a machine or directly onto a workspace with this terminal command. This is like, I don't know if you've ever tried to walk a developer through connecting to a Kubernetes pod and getting a shell to do troubleshooting. It can be like pretty, that's a lot of commands to ask them to do, or a big, one really big long command. With this, if they need to get onto a terminal to do some troubleshooting, or maybe they just like using Vim or whatever, they can just click right in there. They can also run code server, which is VS Code in a browser, as I said before. It works really great. It's really fast. If you're relatively local to your control plane, there's hardly any lag at all. And that's where I mentioned the proxy control planes as well, how before we're spread out all over the world. But you can also run VS Code full. If you look down here in the lower left-hand corner, you can see it's opening a remote connection. And why is it going to Casablanca? Should be going there. I don't know why it's doing this. Oh. Weird. It must have had something on your back. So here we go. You can see it's going to the local admin, and it'll eventually open up. There we go. And you can get shell access there, file access, everything like that. So we do have some other options as well, not just VS Code, and hopefully this will work. This is my Kubernetes instance. I have it's going pretty slow. I'm tapping through my phone because there's like 0 off. We have a couple of really basic things. We also have this instance here where I have Jupyter installed. So same sort of thing. They can click on the terminal. They can get code server. They can run VS Code. They can also run Jupyter in a browser, which is pretty cool. And we also support all the IntelliJ stuff too, JetBrains. And then of course, if you have something that you absolutely can't get to run directly through Coder, well, you can always you can always have it serve up a VNC session or an RDP session as well, and just give them a full desktop there. Probably shouldn't try to demo this with the limited bandwidth. So I'm going to just skip right over that. So how do we do this? Like, how do we create these sorts of things? Coder provides a bunch of starter templates. If you go to templates and go to starter, you'll see that there are templates for just about anything out there, right, that you can think of. All the big cloud providers, Docker, generic Kubernetes. So let's say we're going to develop in Docker. All we do is we click on that and we say we want to use this template, right? And let's just call this the web UI template. And name it web UI. And we're going to say, all right, let's create this template. So what you will see, what it's doing right now, if you look back in code server, you can see that it's unpacking all the Terraform stuff for that. So there we go. It's ready to go. Now we can create a workspace. Let's call it web UI again. Let's call it web UI workspace. And we're going to create this. And this is going to take a few minutes because it's running on my little laptop here. But basically all this is doing is it's going through and it's using Terraform to provision everything. You can see everything. Oh, that actually went pretty quick. If you look back at, if you were watching the Coder server, you'd see all those commands running too. That's gonna take a few seconds to start up. Now, if we look at Docker on this machine, you can see that it is, there it is, it's running right now, the container's up, it's still coming up. Let's take a look at what the template actually is while this is still spinning up. We can look at it through the UI, just saying edit files, and there it is. It's pretty straightforward Terraform. Is anybody not familiar with Terraform at all? Like never heard of it? Okay, it's a declarative language for infrastructure. Think of like Ansible, Chef, Puppet, whatever is great for deploying software. This is great for deploying infrastructure. It's a hashing product. Although we're not in competition with hashing, so we're safe from their recent licensing changes. And like I said, Mike Hashimoto is also a mentor of our code of our members. Anyway, what happens is after it spins up the template, or spins up the Docker container, it goes and it runs this startup script, which installs our agent directly on. That's probably what's taking so long here is installing the agent for myself and potential. But you can put any bash command in here that you want. Right? So there's 3 different ways to configure your workspace, right? You can say you're using Docker images, you can bake whatever software your devs need into the Docker image. When you build it, you can have commands that are run here upon startup that will install what you need. And then we also have a new thing coming out that uses Canico, which is like it's like a dev container. So you fire up a generic container that has pretty much nothing on it, or just the minimum to run, and it will actually build from another Docker file and overlay that FS onto the running container. What that does is that takes some of the responsibility away from the platform operations team and gives it back to the devs, right? So do you want that? Maybe not, but it's an option. So like I said, this is all Terraform. And it's no problem. So let's go back and take a look at our workspace. It should be up by now. There it is. So here we are. We're running our real straightforward, just generic Docker image, and we'll go into the Terraform and how this is built in a minute. We do offer images they're just based on like really stripped down versions of Ubuntu. You don't have to use our images; they're just there to get you started if you want. If it'll run our agent, you can run it here and we'll support it. So pretty much any distro we'll support. Most of our users are using some either a Debian derivative or like UBI, right? Grow UBI. So let's say we wanted to create a template from scratch, right? There's a couple of different ways to do it. If you have the Terraform already written, you can go through the GUI and say create a template and actually upload the files here and give it names and stuff like that. But this is Linux. We're gonna use the CLI. So I happen to have a template here, and then this is on my GitHub. I'll put the link up. You guys can download it. The slides are in there, and the templates will be in there. So this is our OLF 2023 template that we're going to use. Right? If you can see, it's Terraform, right? It's got the lock file. It's got the cache directory. If you look in build, it's just a Docker file, right? And if you look at that Docker file, it's pretty simple, right? This is kind of just enough to get somebody up and get the movement. It's got Git and Go and Vim and things like that. But you could at this point you could bake whatever you want into this Docker file. So we have this here. It's ready to go. So what I'm going to do is I'm just going to use our Photo CLI. If we have there's a template subcommand We can look at the templates we have already installed, right? There's that WebUI one we already looked at. We can also create one from here. Now this is what most people are gonna do. They're not gonna be sitting here typing these commands. They're gonna take their Terraform, they're gonna check it in to their repo, their CI/CD is gonna pick it up and then use these commands to check it out and push it up to Coder. So let's say Coder template, create, just in this directory. You don't have to be in the directory, like you can be elsewhere and just give it a path, but we're just gonna create it here. So yes, we wanna upload it, and you'll see that it's gonna do a bunch of stuff. Basically right now, it's using Terraform on your machine to do a lint check and make sure everything looks good. If you have typos in there or whatever, it will kick you out at this point. So it looks good, it passes muster, so do we want to confirm it? Yes. And then this will push it up. So now we have a Coder template called OLF that's available for users to use. So here we go, there it is. So a developer now can come in and say, all right, I want to create a workspace from here. Call it OLF 1, 2, 3. We're going to create the workspace and give it a minute or so to catch up. So it should be up and running by now if we do a Docker PS. You can see there it is running. And I want to wait for this to come up because I want to do a couple of things in there and show you guys how easy it is to update these things using the how we use, well, in this instance, the Docker volume mounts to preserve the home directories and things like that. So this is going to take a minute. Does anybody have any questions at this point? Nothing. Okay. Another cool thing you can do while we're waiting for this, if you want to use one of our starter templates, how I showed you, you can use a starter template, kind of import it straight in. Oh, here it goes. You can use the tooling here. Let me go in my temp directory. So you could do like a Coder templates list. See all your templates there. Then you can do a Coder template pool. And then we'll just grab the WebUI one and create it. So now it's going to create a vector WebUI. And you can see there it is. There's all your Terraform. And now at this point, you could use this, modify it however you want. Either push it back up directly or check it into your pipeline. So, all right. So our OLF 123 instance is up and ready to go. Has just the basics, code server, things like that. So let's just grab a terminal here. Let's say. Let's make a directory for our source code. Okay. So there's our source code, our empty source code. Let's take a look at what are we actually running on here. We are running on Debian SID. This is a Ubuntu image. So whenever you look at the Debian version, it's always going to say SID. So let's say that we decide we don't want to use Ubuntu now, but we want to keep our environment and things like that. We can go into our Terraform template. We can change our Docker file. All right, so we don't want to use Ubuntu anymore. We want to use good old-fashioned Debian. Okay. So now we've made a pretty big change to our environment. We're switching OSs, right? So we can just use the Coder tooling, say Coder templates push. And it'll do all the same stuff that it did when we created a template. It'll use Terraform to to check over everything, making sure all the resources are available, all the providers are installed, and there we go. So now when we go back to our workspace, we now see that we have an update button, right? We can tell that the workspace has something new that we can restart. And also, if you're out on the main, looking at the main list, you'll see that there's a little outdated icon next to the name of the workspace. So we can say, okay, we want to update this. And what that's going to do is that's going to use Terraform to rip it down. Because the neat thing about Terraform, not only does it stand stuff up, it puts stuff down, right, in the proper order that it's supposed to. You don't ever have to think like, oh, did I erase the home directory, or did I get rid of this whatever weird thing I set up? If you set it up with Terraform, it'll pull it down with Terraform. So now what it did is it pulled that Docker container down, and it's going to start up another one. Let's see. Yeah, this one was created 26 seconds ago, so it's still spinning up. Like I said, it runs. It runs all those different commands when it starts up. So let's just give it a minute to catch up. Any questions at this point? And I'm doing everything as the admin as well. You can create users and things like that too. Our enterprise, our enterprise version, or the enterprise features, I shouldn't say enterprise version, it's all the same version. There are features to create groups as well, so you could have like an everyone group or a project A group or project B group, whatever, and give them access to different templates and different images. Let's see, are we back up yet? No, this one's taking a while. You know what, it's probably pulling. It's probably pulling the image now, so this is going to take a minute. No, there we go. So now this is the same workspace, right? So what did we do before? We fired up a bunch of containers. We went in, we created some source code in our home directory, and we checked what OS we were actually running. Then we went to our template, and we said we don't want to use Ubuntu anymore. We want to use Debian now. So if we want launch a terminal, this and from the developer's perspective, all they're doing is coming in, and all they did was click that update workspace button. So now when we go into the terminal, if we do an ls, there's our source code is still there, right? This is still our home directory. But now when we look at what version of the OS we're running, we are on 12.1. So we're on a completely different OS with literally just a few clicks for this guy. But it preserves the home directory and everything like that. That's all persistent. So that's kind of the end of the main part of the demo. I wanted to show you guys some of the other parts of the tooling. If we look, we can look at see what we have running. If you look now in your SSH config, you'll see that it has all kind of different. It sets up a config for each one of these things, or for each one of these workspaces that you have. So if you say coder list, now say coder SSH, we'll go into our OLF demo. There, we're SSH'd into the instance without any, it's all key based, no passwords, no jumping through hoops, no having to tell the person or tell the developer, oh, the IP is this, the host name is that, or whatever, right? It's all very straightforward. And then you can also check, we have a ping utility as well. So we're gonna try to ping this instance to see how we're connected to it. So you can see, oh, it went pretty quick. The first connection, it was proxied by our DIRT, right? It was proxied over our control plane, and then it immediately graduated that connection to a WireGuard P2P. You can see that right there. The further away you are from an instance, the longer it will take to negotiate that. And if you're on a really bad network connection, it won't promote, it'll still keep everything through the control plane. So now if I wanted to connect to, if I wanted to connect to my instance that's running out in GKE, I'm gonna log in right there. I'm gonna grab a token. Oh, and you can create like long-lived tokens here. So if you're gonna put this in your CI/CD, you could have like coder -- token or whatever your long-lived token is. If you wanted to be able to use this to use your CI/CD to push templates around things like that. So I'm not doing that right now. So I'm just gonna grab a temporary token and whoops. Spell. Okay, so you can see now I've switched the command line tooling over to my stuff that's running out in Kubernetes. You can see here there's Debian, JLab, Jupyter, and on and on and on. You can see those here. So now if I want to do a coder ping for one of those, you'll see that it's going to take a while, if it even can, depending on this connection. It's staying, it's relaying. So my connection isn't clean enough to graduate to WireGuard, basically. And that's no surprise, running over without a connection. So yeah, that's kind of the end of the demo. Let me see. Like I said, we do offer enterprise support. If you use it's all open source. Even the enterprise features are open source, right? It's all on GitHub. It's coder/coder. Is the code for them. The enterprise features are under a different license though, which requires you to be a paying customer. If you use just the open features or just community features, you can get support on our Discord channel. If you pay for an enterprise license, you can use those features plus the enterprise features and get support from engineering. But there's a lot of stuff in here that bigger companies like, better OIDC integration, SCIM, being able to create groups and different roles for different projects, all the auditing and HA as well. You can run as many instances of the control plane container that makes sense for you, and they will all connect back to each other and talk to each other that way. If one of them drops off, you're going to have very limited interruption. Oh, and then also the workspace proxies that I mentioned, right? To be able to proxy out to another cluster on the other side of the world. So there's my GitHub. It's Tim Quinlan. It's just my name. The slides are in there if you want them. The Terraform template that we created for the demos and everything like that as well. It's pretty straightforward stuff. If you're comfy with with Docker or Kubernetes and Terraform, you're well on your way to becoming a pro at this. So here are the links, and like I said, these are all in the slides. Our Twitter handle, our website, our GitHub, and our Discord. So Discord gg.r/coder, that's the community support for Coder, and then my email address as well. Once again, we have our 2.0 launch in a couple of weeks, even though we're 2.1.5, and we will probably be 2.2 by the time this comes out. Well, maybe not 2.2, maybe more like 2.1.7 or 8. So that's it, pretty quick. Does anybody have any questions?
I have Podman installed on my machine instead of Docker.
Mhm.
So I tried just firing up Docker and it didn't want to go. Is there advice on that? Or?
You can probably use the Podman Terraform provider. So when you look at the Terraform file, is this big enough for you guys to see, by the way? You can see that we've defined our required providers for Terraform in here. There's the coder Terraform provider, and then we're using the Docker Terraform provider as well. I think you could probably just slide the Podman one in there. The other thing you could do is you could alias in your shell Docker to Podman, and it should work at that point. I used to work at Red Hat when Podman came out, and we used to tell people that all the time. There's like so much production Podman code that people, the way they ported it to Podman is with the shell alias. So, it works. It's pretty feature compatible.
And then I couldn't get your repository numbers.
Oh, you know what? I didn't. Yes, thank you. You're right. I didn't. I'm in the browser here. I didn't set it to public yet. Here, let me do that right now. There you go. You should be able to get to it now. Thank you for that. Any other questions? Okay, so you may be wondering why I have a giant box of Legos next to me. We are giving away this tonight at 5:55, right before the keynote at the Coder booth. If you want, come by. We have a survey that we would appreciate you guys filling out. And if you fill out the survey, I'll give you a ticket for the raffle. If you request a trial demo, or you request a trial license, or you request a demo, I'll give you extra tickets for that. And since you're here, I'll give you a ticket as well. But you do have to fill out the survey to get that first ticket, and then get the additional tickets as well. So if you've already filled out the survey, I recognize some faces from talking to people. If you've already filled out the survey, just come meet me at the booth, and I'll give you a okay. Well, thank you guys for coming. I'll be around all afternoon and into the evening. So if you have any questions or just want to talk about anything, come hit me up. I wonder if I filled up my iPad with that.
We seem to have gotten it here.
Yeah.
You chose well, or I chose well on your behalf for a superior time slot.
You know, I was honestly a little worried about
it didn't work with the popular container programs and platforms that people wanted. People were wanting the ability to use Kubernetes, people were wanting the ability to use Docker, and that was not available for us in FreeBSD. So we weren't able to do that. Moving to TrueNAS Scale, we're able to pull that in, and we can do that very easy. Diversity of the solutions gave the TrueNAS Scale developers options when it came to container orchestration. That's really the same thing. So we talked about both of those. We talked about jails in TrueNAS Core, how they were getting kind of long in the tooth and difficult to support. Meanwhile, while we implemented the App Store in TrueNAS Scale, it was much, much easier and gave people a easy to use container experience that they were already pretty familiar with. They just Docker or Kubernetes. Scaling out wasn't an option for us with FreeBSD. So that was something that people were asking for, and we really ran into a wall here because we wanted to have a solution that was scale out, where people could add additional nodes and add storage. It fits a lot of different workloads out there that businesses are using, but we couldn't find a way to do it with FreeBSD. We were able to get that running pretty easily with TrueNAS Scale, and now it has scale out SMB. So you really can share it between all those systems very, very, very simply in a uniform fashion. So it's all just feels like one system. High availability of FreeBSD doesn't allow active availability, which is a problem because if you're a big business, you're a big enterprise company, you want to have that active availability. You don't want to have your system go offline and then not have another controller to automatically pick it up. Well, with TrueNAS Scale, we're able to do that. We're able to add active high availability. Then also there's the dynamic development, which everybody here is pretty familiar with. The drivers are quite further ahead with Linux. There's a lot more of them. And because of those drivers and features that are just included with the base OS, that made a lot of sense for us. When you're talking about people wanting like a rich experience, and then you also have the drivers to go along with it and just provide a very rich experience for them out of the box. Oops. I just skipped past that one. Good. All right. Well, as a past community manager, I'd be lying if I said there wasn't a reason for this, but we were excited to grow the community more. Okay, we wanted to get more people in the ecosystem, and this is a great way to do it because, quite frankly, the people who download our software, who download TrueNAS, they're more concerned about a good open source solution than they are about tribal behavior or FreeBSD versus Linux. We just don't have that really in our community, it doesn't seem like. So that's a really good thing. We were worried about that. There was some concern that might be a problem, but it did not end up being one. Because of the widespread adoption of Linux, of course, that makes sense for a company that they would want to compete in an additional market that they couldn't reach otherwise. So that does make a lot of sense there. And Linux offers a comprehensive mix of technologies that allowed us to just build the complete right solution out of the box. So that was a big part of it. As far as the core technologies, I'll kind of just show you what we have, and we broke them down into 8 pieces here just so you can easily see what we're doing, what we're pulling in to make TrueNAS scale. So you can see you have just base TrueNAS, which is TrueNAS Core. We were able to port over pretty well everything that's in TrueNAS Core over to TrueNAS Scale, and then we just added on pieces to it to make the complete finished product. For the kernel, we have Debian, and we are using, I don't think we're on the latest, but our next version bump is going to have the latest, which is 6.1 of Debian. Don't quote me, but we're getting closer. We have OpenZFS 2.0, so most recent edition of that. And the cool thing about this is we were able to take all of the work that we did on OpenZFS from FreeBSD, and it's the exact same system basically that is being used here in Linux. So we were able to just consolidate all of that and use it in both products. We also have Gluster that enables the scale out architecture for us. We have MinIO, which is simple and scalable object storage. That's part of the enterprise functionality of the product. Then we have Kubernetes and Docker support natively. So that's what we're using. We already talked about that quite a bit. The piece that we haven't necessarily talked as much about is the S3 API and the way that it can kind of converse and talk to all these different S3 platforms. The cool thing is TrueNAS Scale and TrueNAS Core both have this capability. TrueNAS Scale just happens to have more of it, where it can work in tandem with a lot of different S3 providers. So that's a great thing, and that API is available to work with a large amount of those. And then we also have KVM, which provides a much richer experience for virtual machines. For our open storage, some of these are protocols, some of them might not be, they're more technologies, but we'll say for our protocols and technologies, we really break it down into the three pieces, where the open storage is going to be your shares like your SMB, NFS, you're going to have iSCSI, you'll have the S3 API for cloud compatibility, and talking back and forth with that. You've got OpenZFS and Gluster and MinIO at the OS level. For open virtualization, we've got Kubernetes, Debian, and KVM in there. And then for open APIs, we also have a REST API inside the product, which is really great. You can make use of if you want to script things and do things of that nature. Also a WebSocket API, Kubernetes, and Helm charts for Kubernetes. And then a lot of people ask, well, what does it look like with the licensing? Well, some of it uses, the majority of it uses BSD, and then there are pieces that have to be MIT and GPL licensed. We're also big on using tool sets that are open source. So you'll see we use things like GitHub, Jenkins, Hugo documentation, things like that for our community. So we're big on dog fooding and using those types of things. We also have, we talked about the community, and the size of the community is really great. That enables us, what we do is we kind of leverage that. We have a lot of alpha and beta testers out in the community that are very, very skilled in the tech field, and we're able to draw on them before we ever let the product get to a place where it hits business or anything like that. We ask people, we say, hey, do you want to be a beta tester? Do you want to be a person who's kind of on the cutting edge and helping us, form this product? And we have quite a lot of people who contribute to that. We have other people that contribute. They're not all developers and testers, but we do have a lot of people who contribute in other ways as well, through documentation, giving talks, and things of that nature, running local groups. So TrueNAS Scale provides the same ease of use you'd expect. If you've used a different TrueNAS product, you're going to be very comfortable using TrueNAS Scale. It's easy to use. It has the reliability of Linux and ZFS, which the OpenZFS 2.0 is very, very mature, considering they've been using it for, gosh, I want to say the last nine years, maybe 10. So even before it came over to Linux, we were working on that. It's got easy patch management and simple upgrades. You can always roll back if you need to. If you have something that goes sideways, you can use snapshots and roll back rather quickly. So quite easy to navigate in that regard. We like to say that it's not so easy that your grandma can do it, but if you're slightly inclined towards tech, you're not going to have a problem doing it. We also have community and professional support available. For TrueNAS Core and TrueNAS Scale, those are community supported. And with TrueNAS Enterprise, when we go to a business and they're asking, hey, what are the solutions you provide? We do have TrueNAS Enterprise where we can offer them 24/7 support for their products. All right. A few other things to note is it's the same web GUI, same web UI updates. So whenever you want to administrate or manage a TrueNAS system, it's really great because you can just go to a browser on the network, type in the IP address, and you're able to manage it all just right there from your browser. So super simple to manage. We have hundreds of QA cycles and thousands of tests for scale. We also have those for core. It's a lot of the same tests, but that's just important for people to understand. It goes through a substantial amount of automated testing with us, with IX systems, and with the developers themselves, and then of course the community. So we already talked about support. We already talked about the community being rather large. It's open project management, and what we mean by that is it's really ran by, a lot of it is democracy. It's like if somebody wants to raise a request or something and they say, hey, I would really love to see this in TrueNAS, they're able to open a ticket on our Jira and people start to vote on it. And when something gets a certain amount of votes, it's very easy for us to pull it in to the software. We already talked about the REST API and CLI, but then we also have True Command multi-system management. This is free for up to 50 drives. It goes by drives. So we just give it away for free. If people want to use it and it's like a home user or a small business, there's no cost there. But the cool thing about True Command is you're able to manage a fleet of systems. If you have 4 or 5 systems, you can manage those all just from one interface. You can move data between, you can do configuration management and stuff of that nature. So it makes it a lot easier when you have a lot of systems to manage. All right, we talked about this earlier, but we do have 3 different trains. And basically those are, that's what makes up our app catalog. So you have community, which are basically anybody can contribute a community app to TrueNAS scale. So that can be done by anybody, and that's QA'd by the community as well. We don't really have a lot to do with that. Now, where IX might come in is when you get into the official train, what we do is we run a minimal amount of QA on those. Okay, now we just make sure everything looks good. Then we just pass it into the app catalog, but there is some QA that's done on that. Then the enterprise train is really just the cream of the crop. Those are the very, very best apps that we actually get behind. And we say, if you're a business customer, we say you can run this in production with full confidence. So. And just to give you an idea of some of the different apps that are available, you have things like BitTorrent, Collabra, Storage, Chia, all these different ones here. So that's just showing some of them, but there's quite a number of good ones. I know one of you was telling me about Pi-hole yesterday. I thought that was pretty cool. So I'm definitely gonna be checking that one out. So some of the questions, one of the probably very first questions I always get is, wait, is TrueNAS Core going away? Because there are a lot of people who really like TrueNAS Core for good reason, because it's reliable and they've used it for many, many years. The answer to that is no, it's not going anywhere. We're going to maintain both. 2 out of every 3 downloads are TrueNAS Core. 1 out of every 3 is TrueNAS Scale. We are seeing TrueNAS Scale growing a little bit faster than TrueNAS Core. But considering our enterprise product is based on TrueNAS Core, it doesn't make sense for us to get rid of it. So we're going to keep maintaining it. It's not even on the agenda right now. Another thing that I get asked quite frequently is there a reason that I should choose Core over Scale? And it really is like we talked about earlier, where it depends on your workflow. It depends on what you're doing. If you just want storage that works, storage that's just very mature and doing well, then TrueNAS Core is probably enough. But if you want to add applications and services that you can just trigger over the network, you can go into that interface and turn those on and off, then you probably want to go with TrueNAS Scale. You're going to have a lot more to choose from there. And who the heck is IX Systems? If you are familiar with IX Systems, feel free to stop by. I won't read the whole thing here. It's probably way too commercially for me anyways, but we're basically, IX Systems is the corporate sponsor of TrueNAS, and it's one of those things where we're a lesser known name or brand, and really a big part of it is we just try to steward and support open source projects. We try to go to these conferences and just make an appearance and enjoy getting to kind of rub shoulders with everybody and shake hands. So we have a facility in San Jose where we manufacture everything. And then our support team is with me over in Knoxville, Tennessee. Next thing I get asked is people ask, well, how is the community receiving it? And we did mention that a little bit earlier. It's been really good, actually. I was quite worried at first when we introduced this that people were going to have a lot more tribal behavior and it was going to become like a FreeBSD versus Linux kind of thing, but that never happened. So that was good. People have been quite supportive, and I think a lot of it is to do with the type of person who's using TrueNAS versus maybe something that's more like a command line operating system or something like that. I think that they're more concerned about, we just want a product that works. We just want something we can use at home, we can spin up easily. It's free, even better. Yeah, absolutely. We're on board with that. So that was a good thing to see that the reception was good. So I wouldn't say that TrueNAS Scale is ready for business yet. One thing that we do like to do is we have this on our website where it's kind of like a matrix where people can go and see how far along it is, and they can see if we're recommending it for general use and things of that nature. But you can see right there, we say coming soon for Scale Enterprise. So we do have the traditional TrueNAS Enterprise available, but we aren't recommending that customers adopt it yet for general use. That's probably going to come in about 6 more months. All right, like I said, I'll post these slides in the channel. I tend to go through them very quickly, so I don't know what time it is, but that's okay if we did. More time for questions and things of that nature if we don't have too much to talk about. All right, so I've got some extra just little gifs in here where you can kind of see how the operating system works. Nothing too interesting there, but right here just shows you how easy it is to install and turn on the service or application rather. All right. Well, thank you for sitting through that talk, and I'd be happy to take your questions if you have any questions about TrueNAS. Doesn't necessarily have to be related to this today or anything like that, but at any rate, please feel welcome to ask some questions if you like.
I got a question. I talked to you yesterday.
Yes.
I installed TrueNAS last night, but after I go to the App Store, it says Kubernetes is not running.
Oh, it says it's not running?
Yes. So I rebooted the NAS and then same thing across the board.
So it's just not, it's like the service just isn't running right now.
And I can't find out where to turn it on at.
Okay, I can show you later.
Okay.
Okay, let me show you later. It'll probably make more sense if I can just point you in the right direction and try to tell you. But let's figure that out, and we'll get that solved for you. Yeah, back to the back.
I've heard, scaling out clustering and sort of things. It has cluster support built in. Is there a reason that you guys pick cluster over just cluster?
Not that I know of. I haven't heard anyone say the reason actually that they decided to use cluster over Lustre. So I don't know any answer to that one specifically. It's a good question though. So.
One of those things I haven't been able to find that in docs or anything.
Yeah.
So I'm just kind of curious.
Yeah, I am curious about that too. Why don't I ask? I'll just ask the developers. I'll just be like, why'd you choose it? And we'll see what they say.
All right,
Yeah, yeah, for sure.
Question. Just for clarification, TrueNAS Scale, is that a distributed storage environment then? TrueNAS server synchronizing data, or?
We don't necessarily call it a distributed system. We do have a distributed system where we have what's called IX storage, and that is where it's completely distributed. We actually have all of our downloads running off of that, and it's using the storage technology to facilitate that basically. But you log in from your TrueNAS system and all that good stuff, and you can do distributed storage. But I wouldn't call Scale necessarily distributed storage because it's more of like, it's just scaling out and building clusters for to add more storage. So, yeah. But yeah, you over there.
So is this, I just want to verify, so does this rely on ZFS too?
Yes.
Scale
Yeah, it does. So both core and scale, the question was, does it rely on ZFS? And both core and scale use the same version, OpenZFS 2.0.
Okay, and what would you say, what would be like the simplest, or like, I guess, first is like, how simple is it just to implement? And then, like, what would be the simplest way to do it? You just want to quickly implement it and set it up?
Oh, like just TrueNAS scale, just get it up and running and let it go?
Like a home context or something. Or
For sure. So there's a built-in installer. You just basically burn it to a disk. You just burn the image to a disk and you install it on the system. Simple to use installer, pretty easy. After the system comes up, it'll give you an IP address. You take your IP address, you log in and set it for static so that you always know the IP address. You don't want to constantly be changing. But after that point, it's completely headless. You don't have to do anything else. So, yeah.
But you do have to make your data set. When you install it, you have to actually set up your hard drives. So if you want all your storage drives actually have to be set up itself.
That's a good point. Yeah, thanks for mentioning that. Yeah. Yes, sir. Back there in the back.
So how's your experience getting ZFS on Linux?
It's actually, well, are you saying with OpenZFS on Linux?
Yeah.
Oh, okay. Because I think there was a project they actually called ZFS on Linux. I'm not sure if that was what became merged together, but it's been really good. Yeah. OpenZFS on Linux has been very good for us. And we haven't had any kind of stability issues, nothing like that. So we're experiencing the same level, it feels like, of reliability between both FreeBSD and Linux. Yeah. Yes, sir?
Like you're building like a home lab, and I think it'd be best to have similar hardware if you were to have multiple servers set up with storage, some type of clustering or
Absolutely, because your connection, if you don't mind, I'll paraphrase, but your question was, how does it affect the performance when you have multiple systems? You might have one that's slower than the others. So that does make a difference because your connection, your throughput is only going to be as good as your slowest connection. So that is something to keep in mind when you're setting up a system like that. So. Yeah.
I've got another question. About what is the largest array that you're aware that your customers are running?
Oh gosh, that's a good question.
Are we talking petabyte or?
Oh yeah.
I've heard of a 172 petabyte array that's right on.
Yeah.
I think that's Macros.
Yeah.
They're using but I don't know if they're using TrueNAS.
Right, that's what I'm curious about.
So our systems, our M-series systems, go up to 7.2 petabytes, and I know several customers that have those. But then I also know people that are going beyond that with multiple systems. I do know another figure that might interest you is we have we're estimating 5 exabytes of data managed right now. So pretty significant as well.
That's not in a single cluster.
Yeah, in a single cluster though, that's,
and
yeah.
I'm curious if with clustering scale,
Yeah.
that 7 petabytes will be expanded and we'll start seeing some fun numbers.
Yeah, I mean, we definitely have some customers with some big ones, but I don't know how big it goes beyond those double digits, if you know what I mean. So that's something that's piqued my curiosity though. So let's find out more about that. Yes.
So I know it runs Debian a little bit, so I can always just, tinker with it myself, but is there any first class support for alternative connectivity standards like RDMA?
I don't know the answer to that question, to be honest with you. I can look into it, but I don't know the answer. But when I ask them about your other question, you can find out.
Okay.
Yeah. I'd rather do it that way than than try to figure it out. Yeah, on the fly. But okay, cool. Yeah.
So OpenZFS, is it built natively into the kernel or is it assigned as a kernel module?
I believe it's a kernel module because if I remember correctly, what happened was there was some kind of kerfuffle with trying to pull it in at the kernel level.
Yeah,
and
because
so
of the CDDL.
exactly.
I was just wondering if you guys were recompiling the Debian kernel to go natively in, because And the main reason I'm asking that is because I'm actually curious on how portable the TrueNAS UI is on other distribution platforms. Since I'm a hardware taker and sometimes I need to run that newer kernel that Debian doesn't offer.
Yeah, that is an interesting thing. I've not heard of anybody taking the GUI and like adapting it to other versions, but yeah, you certainly could, I'd imagine. Yeah, it's quite an interesting thought, though. I hadn't thought of that from that perspective, but it could be done. Very good. Yes, sir.
So earlier, you responded to his question about it being distributed.
Yes.
System and kind of suggested it wasn't. Can you add some color as to why it's not?
When I think of distributed, and forgive me if my understanding is limited here, I'm sure you all could, maybe help fill in the gap for me here. When I think of distributed storage, I'm thinking of hundreds and thousands of nodes all over, almost like a torrent network or something like that. But that's what I was thinking, because we have IX storage and we refer to that as like our distributed storage system. But we just, frankly, we just don't refer to it in that way. But
how many nodes can you scale to then?
You can scale to a lot. You can scale to quite a number of them. I don't know the upper limit, but yeah, quite a lot. Yeah. Very good. Any other questions?
So if you've got a two-node H8 cluster or whatever, and one node goes down, how do you still access the storage from the node that went down? How are you accessing the storage?
Well, it's like constant synchronization, basically. So if you lose one, you still have your other two that are online, and you can always get back to the data that you have on that one as well. Now, if you lose 2 out of 3, then you're going to start getting into problems. But if you just lost like 1 out of 3, it wouldn't be an issue.
Okay, so are the disks kind of independent of your server then?
Are they what now?
Are the disks kind of independent of your servers, so you're kind of connected? Or your servers kind of, so how are the servers and the disk connected, I guess?
Yeah, that's what the scale out ZFS is for, is basically to have them all synchronized between each other. And so that's basically its job, is to make sure that they are all staying aligned. So it's not that the disks are necessarily independent. They're all being managed as if they were a single pool.
Okay.
Yeah.
So each one of those. So is there a pool on each server? I mean, how are you connecting those different pools together? How are those?
That's a good question. I don't know the detail on that, on like what that would look like, but I don't imagine that's the case with snapshots in ZFS. It's like you don't need the entirety of the data necessarily to get back to the point that it was before. It's almost like there's a system of pointers with ZFS that gets you back to where you were before. I'd imagine it's something of that same nature where you don't have to have the complete, set of instructions, if you will, the complete blueprint of the data to get back to it. But that's something I can find out some more on, and we can talk a little bit more about that. Yeah, very good.
The TrueNAS supports RAID and software 0, 1, 5, 10, right?
Yeah, so
without the need of a hardware controller.
You don't need any hardware controller.
Okay.
None at all with scale or core. So that's really a pretty beneficial thing. It's all software level. Yeah.
I'm sorry to interrupt you, give you a heads up, be careful about that. I tried that with my desktop last night. I turned it in. If you enable it on the BIOS, it may not see your SSDs. Because I did that last night. I enabled soft RAID, and I had a 1 terabyte SSD and a 16 terabyte spinning disk. I was going to use the spinning disk for storage, and it only seen the spinning disk. It did not see the SSD.
Yep.
So I had to go back in BIOS and disable RAID, then both drives showed up.
Okay.
If you don't have the exact same drives in your system, it won't read it. So if you have a Western Digital SSD and a NAS, NAS spinning disk,
right,
and another NAS spinning disk, it's only going to see the 2 disks. It's not going to see the SSD because it's not like the same brand or name.
Yeah. And mileage definitely varies when you get into using hardware RAID with TrueNAS, because technically, can it be done? In some cases, yes. Should it be done? No. We always tell people don't use the hardware RAID. Just use OpenZFS. Yeah.
I'm a current core user. I'm migrating from
FreeNAS years ago. Is there a migration tool to copy my existing data and settings to
Yes.
to the new product?
So the question is, if I can paraphrase it, can you go from TrueNAS Core, because you're a current Core user, can you go from Core over Scale? Is there a migration tool? And there is.
Either on the same hardware, or if I buy new hardware, can I transfer everything with new drives?
Either way, you can do both. So it doesn't matter. There's that capability. A lot of people just do it right on the hardware they already have, and they're just like, hey, I just want to go from Core to Scale. That's pretty easy. I always tell people, always make sure you have a backup of your data whenever you're doing some kind of complex upgrade like this, because it is an upgrade that, if something is to go wrong, you lose power or something like that, I would hate for somebody to be in a situation where they can't recover their data or something like that. So always have the data backed up, but yes, there's a migration tool. Yeah, at the very back.
I didn't get to catch till the end, so if you already answered this, you can just totally shut up. But, so let's say I have TrueNAS at home, just playing with it, but I still have sensitive stuff on it. I want to back it up. What would probably be the most beginner-friendly way to back it up?
Probably backing it up to the cloud. You can do simple backups, replication, stuff like that. But yeah, you can use any of the native tools to connect to like an S3 target. So you could connect to AWS, you could do Backblaze, that kind of thing. Those systems where you can basically back your data up into the cloud. It's pretty easy. Yeah, the snapshots, are just happening anyways. You can set the frequency of the snapshots, but you're going to have that anyways. So that's another way that you don't even necessarily have to set. It's just going to be going.
Can you back up the snapshots to a different drive, or does it stay where it's at? Say, for instance, is you take a snapshot of your system and you want to put it on a, like say, another drive, and just in case your system croaks itself and the drives croaks themselves, you can actually roll back, just install TrueNAS and pull the snapshot back and reload it all.
Snapshot offloading.
Yeah, thank you.
Good. I'm glad you all are in the room because I didn't know that one. Thank you. Yes.
Snapshot offloading.
Yeah. Snapshot offloading. Yep. Yeah. Thanks for that, gentlemen. Yeah.
Just real quick on the topic of backups, rsafe.net has a CFS native backup offering where you can they run CSF on up their end, and you can do a CSF send or a Z-pool send or whatever the it's the whole pool, I believe the term. So it's everything. It's not a snapshot. It's literally the whole all the snapshots. Right. Right. And
Yeah, that's cool.
It's
And I think you had your hand up. Yeah.
I haven't played this go yet. I'm going to.
Okay, cool.
But just think I know solve this something is the cluster, and you've had apps, containers and stuff. Can you shut them down and bring them up with a different member? Are they cluster wide? Can I move stuff around? Are they pretty much residential single? Say 4 cluster. Move X.
Yeah, my understanding is if one of them drops off, like say one of the nodes dies, you can just pick it right up with the other ones. You know what I mean? So, yeah, everything should be identical. Yeah, we've actually had internal instances where just a few days ago we lost a node, but it just wasn't a big deal because we had the others. It just kept everything going. So, yeah. Yeah.
With like the VMs and stuff, particularly the network, I'm certain that all of this is possible. Anyways, so it's just like something, but it's curious what you do. I'm more curious about the first party UI support and stuff for more advanced networking stuff. So if I want to do like a bonded VLAN from my VMs and stuff, is that like stuff you have to set on your UI or
I know you can do bonded connections, but I'm just not certain of that specific one of bonded VLAN.
You do have to go into the command line.
Okay.
And do a bonded VLAN.
Okay.
On TrueNAS. You gotta go down, you gotta go to the dark place.
Of course, some of us like that dark place. I don't know about you all. I like the CLI sometimes just
I don't
because it
know,
makes me feel like a hacker.
Debian doesn't theme the kernel, so it's still a white theme on that terminal.
It's still about down the terminal.
If you're using Debian native, they still use a white beam from terminal, so it's not really that dark.
First thing to change. Good deal.
Well, one last, for me, last one, will the VMs pass through, GPUs?
Yeah, it should, yeah, for sure.
There's a setting for that.
Mhm. Yeah, for sure. I've got a couple people that are interested in doing that. Were you I think it may have been you, were you asking about the version of Debian yesterday? Maybe it wasn't. But somebody was asking me about the version of Debian, and so we're about to be on version 6.1, I believe.
I wasn't about, I know I was talking about Telescale with you.
Yeah.
And, I don't think I was talking about that.
Oh, okay.
I think I asked you that yesterday.
Oh, okay.
Yeah. You're actually on Debian 11, not 6.1.
Say again?
You're actually on Debian 11, not 6.1. 6.1 is the kernel.
Oh, kernel is what thank you. Yes.
How different is the, so like, does it use the Debian repos, or does FreeNAS manage their own, like, mirror with changes?
We do, yeah. We have our own mirror that we manage changes on, but we do upstream, as well. So
I'm just curious, like, can you use FreeNAS or TrueNAS scale as a Debian distro, or are you better off using it as like a hypervisor or whatever? And if you needed to use another Debian application in it, you'd be better off doing it in a container or VM. Does that question make sense?
yeah, I think so, because I think
Can
what you're
I treat it
asking.
like it's Debian? Or
Yeah.
treat it like it's VM?
I mean, you were saying yes? Yeah. Yeah, it's one of those things that they always tell us, on the marketing side, they say don't play too much with the CLI, because it's going to get broken. So I try to tell people that, just be careful, because your mileage will vary once you start tinkering under the hood. You could break something pretty easily. So it might make more sense to use it as a hypervisor and spin something up. Yeah. Cool. All right. So appreciate everybody, and go down with your next scale.
Sir, we have a request to share your slides. Do you have them already available publicly online, or is that something that we can address by email?
Yes, I actually am going to make those available right when I go out there. So I'm going to make them available and share the link if that works.
Okay, great. Thanks.
Yeah, sure.
Was it you who was asking about the upgrades and quarters?
Yeah, so the thing about when you create a meeting, they just self-assemble every time you do it. So even if you put them on another system, as long as they're all present, they'll still self-assemble. So all you have to do really is just write the new OS to your boot drive. Be careful with that. They should come back up. Yeah. I've gone through the same like panic as you, right? Because I'm really nervous about it.
Yeah.
My machine's powered up, just unplug out.
That's what I did before. When I
Exactly,
moved TrueNAS, well, I don't accidentally let my drill.
Yeah, exactly, yeah. That's the thing. And because, like, when the drives, they're all demanded information.
That's the thing that's man, because
That's a lot of safety.
Outside sheet tells you how to set up on the phone.
Oh, nice.
Oh, sorry. I forgot what was never know been what I asked.
Yes, yes, you can use the microphone. Please do. And it matters from person to person where you wear your microphone. But I would recommend the top of your collar.
It's all right.
Like closer to your neck.
Okay, I think let's start. My name is Liang Yan. I'm a software engineer from the Digital Ocean. I'm sure if you've heard that. The public cloud provider. Before that, I worked for Rooster Linux, and so kind of a open source guy. This is my sixth time being here. Feel like I went here last time, just like yesterday. So and today I'm going to give a talk about machine learning, more specifically distributed machine learning. So flex flow. People may asking like, what's flex flow? If it's one sentence, like here, it's like a framework that could provide you optimal, I wouldn't say the best, but optimal parallelism strategy for your GPU cloud cluster automatically. Now people may see that, Liang, I only understand one word in this sentence, automatically. So what the real flex flow it is? Like, what is a GPU cluster? So it's more like a server, a GPU server, a server with a GPU, and multiple servers there, and build a system. And they people be asking like, what's the parallel strategy? So it's kind of a way like to make this the whole system work more efficient. In this moment, people may be asking like, why do I want to run in a cluster? Why can't I just run my stuff in my laptop, in my workstation? That's true. That's also my answer. In that way, you don't need to care about any of these things. So here, this is the session we are going to answer all questions. First, I think like why, I will explain why do we want to run in a cluster in a distributed way, rather than just in your own workstation. Then we'll see like how the distributed machine learning system working today outside. And then we are going to the flex flow, the exact way we are doing, and the exact work that I'm working on that to extend the flex flow. We also give a practice like to the AlexNet in flex flow. So here, let's begin. I want to maybe a quick question, like anyone knows the LLM? That doesn't, anyone here doesn't know what the LLM means? Large language model, the ChatGPT. It seems everyone these days. So ChatGPT is one of the specific LLM, large language model. And this is what it looks like. It's big, it's very big. And here is the most popular models today. And if you can see the benchline here, that's for $175 billion. Not dollar, the parameters there. So you can think that big models with such big parameters there, it's very difficult to put it in just one machine, in your laptop. I think sometimes, yeah, with the bigger, the best GPU there, you might put it on one lower. Like even the bottom is like 7 billion parameters there. And the other side is like the depth, because as we know, the machine learning is the two most important part. You must have a very good data set there, and then you must have a very good model to train your data set there. So we know that the model is very big today. The data set is also getting bigger. And you can see the purple side is for the language, the text data set. The other side is the vision, like the image picture of that there. So it's also kind of keep going this year, these years. So you can even also like put it just in one machine. So here it comes to the question like, how could I do that in this way? Like, even we don't thinking about the distributed machine learning, we're just thinking about the distributed system. How do we do that? I think, like if we are doing a too difficult task there, I think the straightforward way is like we want to split it. And we schedule to different people, make it work, and then we put all the results together, and then to make it done, mark it down. So that's exactly how distributed machine learning working here. And in these days, there are too many parallelism or split we using. Because we just said that data is important, the data and the model is the two main elements of machine learning. So the split is also based on these two ways. So we can split the data. That's the straightforward way, very easy. You can just, I think it's already used everywhere. Like you have two mass data, you can just split multiple ways to run on multiple machines. The other way is how to split your model. That's kind of tricky. It's I'm not sure if you saw some kind of deep learning model. It would have many layers. Each layer have different kind of operator. And for this way, there's also kind of two ways to split. One way is like it's so many layers, we can just split with the layer, and we distribute this layer to this machine, this layer to this machine, and then we put it together. That's the basic model parallelism. There's also another way, it's like each layer, it could also split. So we can say we split smaller and smaller, we could get more and more worker to do it. With this layer split, the split inside of the layer, it becomes the pipeline. And also, it also comes to a new one called the operator parallelism. Operator here is kind of a mathematical concept. Like today, when we're doing machine learning, we know it's most about the math. And we know that we need to run some very complicated math there, and we need to use the GPU to do that. So it can conclude to some basic mathematical equation there. So we need to use some basic CUDA kernel function. And we write an operator function like the PyTorch or TensorFlow. So we could run multiple CUDA kernel functions into one operator function. And based on that, so now we have this operator idea. We can also split this operator in multiple ways here. There's already kind of a framework on the other side. The Harvard is a very famous one for the Uber. How do they do their machine learning framework? There's also the TensorFlow, PyTorch. And for the pipeline, it's Google G pipeline. So it's more like academic area. Operator parallelism is pretty new. It's all more specific. Today, the flex flow is part of it. And then there's also one flow minus 4 there. So yeah, like I said, the data acquisition is quite simple. Straightforward. Here is the model. Like we can split different layer to 4 devices here. We can also split each layer to multiple machines to build a pipeline to make it work. And we talked about the split. Now we need to put them together to mark the real things down. There's also two ways there outside to do it. One is called the parameter server. It's using a CS mode, like it have this parameter server to get all the information here and do the reduce, add, sum operation, and then to broadcast to all the workers to let them know. The other way is the ring reduce or reduce. It's like it split all the model in multiple ways, and once it is done one, it passes to the other, and then keep going unless it's done. So actually, yeah, a parameter server is more easier to implement, but it has bottleneck. So it's like when things get scalar, multiple, like thousand or 10,000 GPU there, it need like multiple parameters over there. So in this case, we can see that the performance is not goes faster as we expect. However, the other way, the ring or reduce fix this problem. It kind of has better performance. It has a linear performance relationship with GPU. Like if we add more GPU, we can see the system performance is keep going. But in parameter server, we can see once get into a limit there, it will keep still, don't increase very often. And yeah, now today we come into the flat flow architecture, the flat flow. Yeah, probably you don't heard it. It's more of an academic project. It's started from the CMU and currently quite actively developed by CMU, Stanford, MIT, and also some researchers from NVIDIA. It's actually based on MIT project called Legion. Legion will do all the task distribution and the machine map there. So in this way, FlexFlow only focus on the machine learning task, the operator exactly, that work, and how to split that work, how to pass to the whole system. And yeah, so now it comes to the question, like assume we have this question here, we just split into 1,000 pieces there. Now, and then we also have like 100 machine workers there. How could we like assign efficiently? It's actually using a search algorithm here. It's like I just randomly assign each work task pieces into the worker and see how it will doing. So it's kind of a search, like eventually it will find the best strategy, the best combination, which we call the parallel strategy earlier. So it's quite a straightforward idea, though it needs a lot of others, like we need to build a simulator or platform, kind of a simulation all the things to make sure it would similar with the real environment. The other one is like we needed to build a custom model to make sure which is better. Why would we, so this strategy is optimal, but the others are not. So the other thing is like, so we just keep searching and calculation after a number of iterations, it will finally get an optimized parallel strategy. So now it comes to how to split. We talked earlier that when splitting the split, there's only two ways, the depth and the model. But here, it actually added more layer, more. It's simple, like if you put the work, you could split the work more, like more pieces there, you can definitely assign to more people. The granularity, the smaller, you could make it more efficient. So besides that, the model, it actually focuses on the operator, focused on the function itself. It will say like this operator, like convolution, pull, add, dimension. So in that way, based on this operator, we're also looking like what kind of parameters it has. Like for example, if we're looking at an image, we know that from digital format for image, it's the channel times the width times the height. So we can see the channel here is the parameter. The attribute is kind of the attribute of the tensor itself, the image itself. So in this way, we can split one operator into 4 dimensions. In this way, we can assign this four works into 4 GPU or even more, like 8 or 6. So 16. So in this way, we have a very good split mechanism here. And like I said, we are actually doing a simulation. We are doing a search algorithm to find the best way. So we need to construct an operator. We need to build all the deep learning DNA is kind of have a different layer there, but we rebuilt it with a task operator task graph here. It's more like the data flow in a mathematical way. We also need to construct the device topology. Like we have so many servers there. This server runs this CPU, and this server has this kind of a number of GPU, this model. The other has different. And the machine will connect with the GPU could connect with the PCIe device. PCIe bus as PCIe device. It could also connect with NVLink, a new kind of a bus model by NVIDIA. It can also connect by the network. So in this way, we have the whole topology of the whole cluster. That's why we can simulate it. And with that, we using our search algorithm there. We just randomly assign this work to this GPU, and then we see how it goes. Eventually, we'll find we're not like unlimited to run that. We give it a kind of a iteration. So after this iteration, we'll get a best result. And then eventually, we put this one in the real environment, the distributed running time. We get the real. So it's like we calculated the cost. The cost is kind of to running all the kind of a simulation to get a time, and then to compute with the last best one. So it's just a search algorithm here, and yeah, to make it fair and make it objective, we need to using a random algorithm here, and each we make sure each time it's we need to cover as much possible as much possibility as possible. So and this is how we run how it implemented with the simulator there. So it's better idea like split all the deep learning network into based on like the forward training and grading, and then get the backward propagation. And then in this one, we did one iteration. So this kind of simulator is simulating all of the real environment. And then it also consider the dependency. Like when we're doing the work, sometimes we need to wait until the other one is ready to make it a real work. We're also thinking about the thing like the step 3B. Like earlier it all split and assigned to different workers. Step 3B here is we collect all the information back to get a general result of the whole iteration. In this way, we get one iteration done. So we get one, here we'll get one result for one parallel strategy. So we just keep going and going. Eventually, we'll get the best strategy. So just like I said here, for this simulator, the flex flow using the Legion from MIT, and it actually, so when we doing the simulator, we can't make update there. So when it comes to the event of one operator, one function, we need to know the real time running for this operator. So we need to put it in the real GPU to see the time here. And for the best part of the flex flow is it all thinks that all the machines are same. So all the cluster, even you have 1,000 GPU there, the exact thing they'll assume. And so you can just run one machine there to run each operator, and you can see that this is how it works. Then put all the communication costs there, like the network, how long we're trying to transfer this data from this machine to that machine. So in that way, you could get a very good hardware simulation. But this is not the real case. In real environment, in real data center, we may have different, like because of the budget or because of the plan, multiple years plan there. So we may start from the V100 goes to the A100 and the H100. People may thinking, well, once we can't get rid of the old one. It is still the asset for the company. So eventually we are facing this situation. Like in your data center, in your cluster system, you might have different GPUs there, different kind of server CPUs there. So in this way, this is what we are trying to conquer here, to make it more flexible, to give the flex flow the capability to close to the real heterogeneous architecture environment. So yeah, now yes. So here let's see how it really works here. I was trying to the title here is called Optimal Parallel Strategy for LLM. But actually, LLM, the large language model, is actually using the transfer network. So I tried to get that one, but got some issues. Now I changed it to the AlexNet here. It's also a very famous deep learning network. But so far, like what I showed you for all the large language model, ChatGPT, they're actually more using the transformer. So let's back to the AlexNet here. So like I said, it has the multiple layers there. Here we just use 10, but in a real case, it might go to 1,000 layers there. That's why we have kind of 100 billion parameters for one model. That's huge. And you can see each layer, the layer is kind of split as an operator. Each layer has a kind of multiple operator. Operator is basically how you calculate the result here. You can use like, if it's a convolution function, you might need a control function there provided by the CUDA, NVIDIA. Or you can, or some operator is very simple. It's just a sum, the A plus B. That's also operator. That could be done easily by CPU. So you can see it will go eventually like we feed all this kind of information, all the data. Eventually it gives us a result we want to get. For example, we can feed if we want to training marketing like release housing price model there. We feed all the information from the front, like the house size, the house year, how many years it already, the location, and the price, the previous price, the neighborhood price. We feed the data. We set up this, we design this framework, this many layers. Eventually, it will come to the last piece there. It's like it will $300,000 for this one. It will give us a range, very close range, like maybe like even like 10,000 range price. And the more data you had, the better model you design, the more accurate result you get. That's why like when we run the ChatGPT today, we feel like it's very like a human person talking with us. So this is kind of the basic idea how the machine learning works. And from that graphic design, layer design, here we kind of decentralize to the operator. Like when we input some data, that's the picture, like a 3-channel, 299 wide, 299, 299 height. And then we get so many layers. We do the convolution, contour, mostly the CONV and pull flat. And then we do a flat. We try to convert the data into one kind of the real result we want to get there. So, and yeah, from here we get the operator layer. That's exactly what the flag flow want to use. And the flag flow will put the AlexNet, all the kind of model into this way, like to start the flag flow configuration and get all the tensor, the operator graph there, and then it will check if you already has a best strategy. If not, it goes to the simulator and the searching algorithm, and then get the best result. Once got the result, it will put in the best strategy into a real time to calculate to print the final results. So strategy. This is a strategy data looks like. So it has the operator, one operator. Because one model could have the multiple operators multiple times, theme operators multiple times. So, but it started with this operator, and it will give it the operator type. If it's a CPU type operator, like the add, subtract, or if it's a GPU type of operator, like we are doing the convolution, pull, the stuff there, flag. So, and then it will give like how many dimensions we assign this operator. Like we can split into 4 GPU, we can split it into like, it's all like power of 2. We can get 4, 16, something like that. So we can, and here it has 4 dimensions, each dimension, how to split each dimension. So eventually, after the flag flow, all the AlexNet network, we can see the so many layers, it will become this operator. And this operator with one strategy. So, and then once get the best strategy, you can put it back to the legend and in a real distributed system. So I think this is also like what PyTorch or TensorFlow doing today. It's just not as this much lower than flexible here. So yeah, this would be eventually like it will looks like the for the AlexNet. This is an induction net actually. So we can see so many layers. Each layer for the vertical side, it means the data parallel. Like it will split into 4 GPUs for the just running. It will put all the data into 4 pieces there, and each one will run in 1 GPU. And from the horizon side, it's the model parallelism. It split your operator into different GPU there. So eventually, all it will come from the input, goes layer operator, and then goes to the output. So this will be a look from the code perspective, actually mathematical perspective. And from here, like, so what it looks like from the result, like, why should we want to use it? Like, we understand you have better storage space, you split more smaller pieces than on the outside. You focus on the operator, and you have a very good search algorithm. You search as much possible possibility as possible to get a very good strategy. That's all good, and it's so. But how good? This is actually good. So we did some. So the author here did some comparison between the general data parallel, which is the most popular side today. It also has some expert design, like a domain expert, research scientist, or even a professor to do in there, and then the flexible automatically doing things for you. So it kind of has much bigger throughput for like to let the samples, all the images going through all your system, and then it's even faster than that. The time you can run the iteration much faster here. It could even like think as export here. So data transfer, it has the best data transfer in picture B, and per iteration, it also has the better execution time there. And it has better converse time than TensorFlow. Like it's for TensorFlow, it might need 20 hours to make the result convert. But for FlexFlow, it's only like 15 hours. That's a lot. Also, like people be thinking, we are using a simulator. Why? How is accurate? Because we already have the general results, so that prove that it's in practice, it's effective. And even for the simulator itself, it's actually very close to real physical environment. There are some errors here for sure, but I think if you see the trend here, it actually have a linear relationship between a simulator and the physical servers there. So here, now we see the flag flow. So actually flag flow is getting more and more popular. We only focus on this simulator and find a best parallel strategy for the distributed machine learning system, but it can do much more. For example, they actually doing the operator fusion. We can do one operator in one GPU per time, but we can actually combine the multiple operator in one and do it one time in the GPU, making it much faster. Also, as just recently, I think last month, we also put the flag flow into inference, and so it has much better inference performance. And they even support the AMD, not only NVIDIA GPU. We also support AMD ROC there. So, but again, still, our focus, my focus is still on the simulator and the first algorithm, but I'm just trying to extend the device topology, like to make it support more and more different machine type, GPU type there, make it more practice. So yeah, I think that's all. Thanks. Hope you find something interesting. Let me know if you have any questions.
Are you assuming all of your nodes are static in their knowledge, or?
Yes, you're right.
Okay.
Yeah, I think so. All the nodes are exact same. That's
Okay.
actually in some situation it's actually true. Like if you are going to the national lab, they running the 1,000 nodes. They put the one temperature, so it's the same.
Yeah, the one example I use right now is you have a room of 50 people, 50 nodes, and you ask a question, and there'll be maybe one person in the room that knows that answer. They answer the question, and the other 49 learn from that. And so, but then you ask another question, and another node will know that answer, and that's, yeah.
Yes, yes.
Okay.
In this way, yeah, it's all same. So like even the simulator don't need to compare about. It's all equal to the schedule. That's another you actually ask very good question, because in my work here, if we are trying to make it about the heterogeneous GPU, different machine, we need to create a profiling database for all these kind of machines there. So the scheduler could make a better decision. Like it also needed to know like the workload from this operator, and then the match a better, more exact, or more fit. It's not like that. It's more fit. We don't want waste. We don't want to like limit. Like that would be about the penalty. Yeah.
Perfect.
It's kind of interesting. That's that's MIT working here.
Yeah, let me get that. I want to take.
This one.
I was just while you were talking, I went out and looked at some of your work, and I thought, your links.
Oh,
there you go.
thank you.
Probably lost a lot of people.
Yeah,
There's not many people working on this technology right now. It's really up and coming.
It's kind of too theoretical here.
I'm noticing your polo shirt, so I take it you're a little bit of HPC over there.
From Stanford University.
Mhm.
Yeah.
So.
Wonderful.
Yeah, it's just, it's the basic problem. You have a long problem.
Well, the basic problem is that everybody assumes everything's static, and that all nodes don't have the answer. So in your first slide, showing the different data sources out there, the repositories, some of the repositories are quite large and some are small. And the idea is to make all the nodes eventually the same size of sharing information. Right. I kind of said that, right? It's, yeah, it's,
Okay.
yeah.
So eventually, all the nodes get all the data.
Exactly, because right now, even with ChatGPT-4, you can go out there and go, oh, well, it's drawing from a large data source. And you can still go out there and ask questions, and the answers you get are totally irrelevant. I was demonstrating that to somebody earlier today. I said, well, watch this. And we asked it a question of something that we knew the answer. It came back with a very definitive answer. It sounded good, but it wasn't correct. And so you have to keep saying, can you refine it? Can you reiterate? Can you, and then eventually what it's doing is it knows that particular source wasn't correct, that node wasn't correct. So it's going to another node to retrieve information. You confirm that, oh yeah, that one's right. And once that comes back, it says, oh, okay, that's the definitive source. That's it. Then what you need to do is take and distribute that to all the other sources that it's drawing from to get the right conclusion. Yeah.
Are you done already?
Well, that's what scares me about AI. Everybody goes, "Oh, it's scary. It knows everything." I go, no, it only knows what it's learned from. It can't. We always say you can't go to ChatGPT and say, "What stock should I buy next week?" So I can make a lot of money.
Yeah. So we're gonna have Susie back to back coming up here at the Open Source Solution stage. And you're rocking another one of my classic designs of OLF t-shirts. Yay!
2008 one, yeah.
Corporations are if you use it correctly, it's a great tool because use it for formulating the basis of reports and things like that. And you're not going to create a report, turn it in. You're going to use it as a base structure and then go through and validate what it's returned with what you found out. Make the corrections. And
look at that! Wow,
it's going to save.
I used to
time.
leave myself 15 minutes for projector adjusting.
Everybody says,
oh,
it's going to make a
great stuff just works, you know.
Yeah, you're still on the live stream.
Draw me a painting in the style of Monet.
I didn't turn it off from last talk. Maybe I can see whether or not this is a good.
Hopefully it's
going to be a.
I guess I should show make sure my demos can look.
Yeah, demo is a demo.
Yeah. I'll go outside and test the audio on it. Wait a second. You're still mic'd.
What do we use the AI for?
Don't worry about it here with all your stuff in your coffee and the microphone. No.
I would say we go through, we say, create a, well, one thing I would say about creating a test report, creating an engineering report based on this particular style. Or I can go out there and say, create a training agenda for a certain type of class, so they can go on and do that. And it's.
I would wear mics, but I have a voice that I tend to project, so usually I get people.
You know what? Do you remember whenever I came out to see you in Chicago at the McDonald's campus?
Oh, yes, I remember.
Yeah, you build the room well.
Exactly.
Well, you know, I've been doing presentations for a really long time.
I'll say something.
And I had 25 years
in Pune, India,
where I was
last month,
in
and I said
production of a Christmas
all
carol every Christmas.
And I go, oh,
and I had nearly every male lead part, male part, including
Oh,
being
wow.
Scrooged twice,
I
and
said, I'm gonna tell you exactly
Fezziwig
what Googled.
9
I said,
times.
you just
and
Googled what I said.
all these different
I'll tell
parts,
you
so
what
I
Google
got used to being
I
a
said,
stage
because
presence. So
what I'm telling you
how it goes.
has not been
How you
published
doing,
out
man?
where Google has access to it. So Google is using the term that it has access to.
Yeah, well, you know,
I'm stating to you, it's not been published.
I'm really having a good
Same
time.
with
You're
AI.
gonna see
AI doesn't have
something
access to that data.
nobody else has seen yet. So
It's like the writers in California right now.
yeah, there.
They're gonna lose their
Yes,
job because
sir.
AI is gonna create television shows.
This Uni server
How is it?
is running in a container on
You
Podman.
look at a television show that was written.
So
Inactive nodes work on
The old Dick Van Dyke
Huh?
show.
Click on
Was
inactive
written
nodes,
years
it can
ago.
work right.
And you look at television shows that are written now, and
Where?
those shows are derivatives of
I don't have
political
any
events that have
inactive
happened and
nodes.
things like that. Well, AI has no idea what a political event is gonna happen
Oh,
in
that
50
one?
years. So how's it going to write a
In the current.
television show?
Oh,
without
well, you know
adapting
what's
to some events?
happening,
There's a fix up in Git
this one,
Repository.
oh, it's, I gotta log in again, right?
It's
Yeah.
fun.
I saw the developers put a fix out
Did you
that
work it?
they need to bundle it.
Yeah.
So
Did you work at this one? Where,
No, I actually
There-
work,
there aren't any
in,
inactives.
the Detroit area.
so that's
For
accurate,
an
right?
automotive company. And, working with their,
But this is actually ahead
area they
of
call
where
FMEA.
it says
risk
Uni
analysis
2023-04.
and risk avoidance.
are you running the
And
current?
we're using
But it's
AI
ahead
tools
of
right
that.
now to
There's,
go through.
because
and-
there's a
and
feature
look at
in here
everything, all the issues that are coming.
that I'm gonna show you,
And predict. what
that's
could
not
possibly
on my
fail
other 2023-04.
You're at
based
2024,
based on events that have already happened.
If you're
If I
at
was,
the
that's what I'm
latest,
telling
the
the
head, it
companies
works.
now, I
Fix
can't,
out there.
I can't tell
Okay.
them what's gonna fail based on,
So I have another one,
if I have no data as to what has already failed.
yeah, so if I refresh
So in
this
the
one,
case they
it's
say
probably make
things
me
like,
log in again.
If I know that you're using a certain type of metal component and you've had failures in the past, that you're going through Colorado, at,
So on this
20,000
one,
feet,
if I
at,
click on
0
inactive
degrees
here,
Celsius, and you've had failures with this
it does
particular
what you
welding
said.
technique with a metal, then
But
when
my-
you start designing a product,
This one,
using that same
I
technique,
click on
I can tell you
inactive,
that
Probably fixed.
based on.
and it's right.
events of the past, you're gonna see
So,
failures.
and there's another feature
Yeah.
of this one
So
that's
that's
also
a very
not
good use
in
for AI.
2023-04. So if you go to, I'm gonna go to that tab here. I think it's not that one, this one. So if I click on system groups here,
Yeah.
system groups, yeah. And if I go to any of these, I mean, like, I can go to infrastructure, and there is a new column here that is not there on this server.
Okay.
But over here on this server, if I go to system groups,
You guys added.
and I go to Apache web server, I have recurring actions,
Interesting.
which I'm gonna also be showing that today. So I don't wanna give
Not gonna
away the
spoil it
farm
for me,
just
huh?
yet.
I haven't heard anything about this yet. I didn't see anything.
Oh,
in any of
you're
it.
gonna like it, because it gives you the power to do things, that we haven't been able to do before. So I'm thinking you're gonna like it. So, okay, so my demo is over there, and that's all working. This is complicated because I'm actually connected to two different VPNs at the same time. And it can't do DNS resolution, so I have to use IP addresses for everything. Because of that. Because so I have one VPN that's going to the school that I manage their servers, and that's the one that has the older version essentially of 2023-04. And then this one is actually running out of AWS. And then this one, this is another one, if I log out here and log back in, this one is running on my laptop at home. So none of these are here, and all of them are remote. But I have a reason why, like this one, I'm managing Alma 9, Debian 11, Leap Micro, and SLIS 15 SP5. Right? And the other one, I'm managing Rocky and Ubuntu and OpenSUSE. So I'm trying to show different things, right? But this one also is in containers. So I'm gonna guess that this one has your feature fix, right? Inactive. Yep, it's fixed.
Current release, that's the one thing that we've noticed, that the inactive nodes, because we have a lot of servers, and I check it periodically, and it was one of the first things I noticed. I'm like, wait a minute, these aren't inactive, these are active, why are they showing up? I went out and looked, and the developer got a report of it. I commented on it, and then he fixed it a few weeks later. It took a little while to fix, but
Unfortunately,
we're having trouble with upstream SUSE repositories for the last 2 weeks.
oh, really?
I've got a case open in the SUSE manager because we apparently from our data center we're hitting a route that's not good. Repositories are getting timeouts. And when I first started talking to them, I was working from our Uni servers, and like, yeah, we don't want to help you. Like, I'm not asking for help on Uni. I know you don't support that. I want to help with the repositories that broke. It took me standing up the SUSE manager server and saying, okay, here, we got support. It's still not working here. Now help. Now they're helping.
Well, I cheat because I go directly to the developers because I'm on the same team with those guys, right?
Yeah, they told me they wouldn't fix our ULN problem in the SUSE manager.
Yeah, I was part of that, telling you that.
Yeah, you were one of the people that told me no.
I was.
I was wondering, I was gonna ask you about that.
Yeah, I was, and I have a good reason. I think I have a good reason.
It makes it a little sketchy that you guys say you support Oracle Linux 6 on your website.
Oh, yeah, that's also a problem.
Because
Oracle 6
If
is
you
a
don't support
problem.
ULN, you don't really support Oracle Linux 6.
Well, we support the content of the ULN. Your connection to it is between you and Oracle. And the way that that connection is enabled, because the mechanism, Oracle is not supporting us connecting to ULN, okay? So it makes it really hard for us to do that handoff without that between ULN and SUSE Manager having that cache buffer serve localized essentially a proxy of ULN that Oracle supports. It's sort of like RMT, and then we can consume that. Because we had so many customers, not just you, where the ULN side is broken and we can't tell if it's Oracle's mirrors, if it's credential related. It was really ugly.
You just have to buy a subscription.
You want us to go subscribe to something from Oracle?
Yeah, buy a subscriction.
Great,
One
okay,
Oracle Linux
well,
subscription, Don. That's all you need.
It's probably not gonna happen today. Just gonna tell you that. So this is the container host that's running Uyuni in containers. So if I go to, if I do df minus th here, you can see I have this 218 gig XFS logical volume mounted on VAR-like container storage. So this is where all the stuff, the persistent storage is mapped right now for Uyuni. So if you go to that, CD2 VAR containers. Did I type it right?
When's the next release going to come out?
That is also a fair question. So you get everything you pay for with Uyuni.
I'm going to tell me about all these great features and I'm not giving it to me for a while.
This is the mapped volumes for Uyuni right now in containers. There's 25 mapped persistent volumes in that container. We had fewer and we ran into lots of problems. I'm hoping that this is the last round of them. I've been working with the developers on doing this, but you'd see things like VAR spacewalk and VAR PGSQL, you can kind of imagine what those would be.
Yeah.
But all of these tuning configuration files in Etsy where you're making changes in how much memory Tomcat JVM, for example, gets. I want that to persist even when I upgrade the container, right? So we have to make them separately mapped volumes. These are automatically genned for you when you do the install in containers, so it's not granularly controlled. This is bonus content for those of you who are wondering. So these get created. I put all my disk space in this VAR-like container storage, and then it just starts consuming it. We're going to start doing some differentiation, so you'll be able to separately map for Postgres, for example, so that you have higher speed storage for the database, and maybe a lower speed storage where the RPMs are for VAR spacewalk, all those kind of things. So anyway, that's this is kind of a custom thing. Nobody's ever seen this except internal.
There's no intent for you guys to stop supporting it on OpenSUSE straight, like bare metal or VM, right?
Yes, there is. Absolutely intent. So
you guys are going container only?
Yes, sir. It will be container only on Podman very soon. Coming
Podman.
soon to a server near you. Yes, sir, it will.
Why is the push for that?
Maybe I should answer that question during my presentation.
Okay.
So I got a few more minutes here. I hope those of you in the audience are not offended by my use of a Mac.
Not at all.
Not at all? Okay, well, good. Yeah. Yeah. At SUSE, I was like, okay, so did we stop? Are we selling desktop solutions right now? No. Okay, then why do I care? I kind of don't care, right? So run on Mac, run on Windows if you want to.
I left my Windows laptop.
Did you?
Still use
Yeah.
Windows.
Well, this one's actually my personal Mac. I wanted something where it wasn't work, right? So I had never had work-life separation until I bought this laptop. I'd always used my work PC for everything. And, you know, I'm too old to be playing it. I just really shouldn't. So, a few more minutes here before we get started.
So what is your company about?
I work for SUSE.
Okay.
We are open source software company, started as a Linux distribution
Yeah.
In 1992.
Red Hat of Europe.
Yes, sir. We are very popular in the EU, and we're headquartered in Nuremberg. So, significant German flavors.
Yep.
And if you like German engineered things, then you might like SUSE product. But we also own Rancher, Kubernetes management cluster managing company. So, and we're marrying the two in our offerings. So a lot of our direction is toward containers and Kubernetes. And that's driving some of what you'll get to see today with the Uni changes that I was just explaining earlier.
Were we originally somewhat assimilated or similar to the Sun OS versions?
So
I seem to remember a story like that.
Yeah, actually, there was a period of time where there was some synergies with Solaris stuff that had our desktop-y things in there.
Okay.
But that's long ago been relegated to the bottom of a New Jersey landfill.
Mm-hmm.
So if you really wish to recover some of that, you're on your own.
I'll be up there in 2 weeks. I'll take a look.
Will ya? Yeah. Actually, I'll tell you a story. So I was at one of my customers in Indianapolis, and I said, okay, I'm going to be here today. I get there about 10 o'clock. Whatever of you guys want to go out for lunch, you're all willing to join me. You know, I have vendor money, so we'll pay for lunch for you and everything. Oh, no. Nobody can join you for lunch today. Why is that? Well, today's a very special day because the Crusher is coming, and our retired Solaris server, Spock, is going to be crushed today. So we all brought our lunches to sit on the back dock to watch this happen. So it was quite a monumental occurrence. You know, lots of cheering and clapping and sharing of peanut butter and jelly. It was really fun.
It's better to do that IBM 360.
It was pretty cool. It was big enough to be worthy. Yeah. They had a storage cabinet and a couple other peripheral pieces that were part of the metal stamping, right? Okay. All right, well, do I have are you my introducer?
You're a man who needs no introduction, Mr. Don Vosberg. How many times have you spoken at OLF?
At least 12.
All right, I'll buy
So
that.
it's a lot. I haven't kept track personally. I probably could. I have copies of my old presentations that no one cares about anymore. But hi, my name is Don. I'm an open source and systems management enthusiast. I'm an old sysadmin guy who turned into a vendor guy who turned into an open source guy. I'm also, in my day job, I'm product manager for SUSE Manager. So I work for a SUSE software company in Germany. And when people ask me what I do, I always tell them I sell free software for millions of dollars. That usually is not the end of the questioning, but it does sort of spark some conversation. But today I'm about the open source side of it, so we're going to be talking exclusively about Uyuni. And some of you, how many of you have ever installed Uyuni and run Uyuni in your world? Oh yes, the Jasons. Yes, you've played with it a little bit? Okay, well today we'll talk about it and I'm going to show you an Uyuni server that I'm sure you never tried to install it the way that I'm doing it today. I always pick stupid to show for my demos. I don't know if any of you do this, if you present publicly or you try to do demonstrations, but I personally get bored just showing easy stuff that's on release software that's supposed to work. I always try doing broken things or things that nobody's tried before or features I've never attempted. And this week was no exception. Now, the one advantage that I have is a direct line to the developers. So as recently as yesterday, a developer in Lisbon, Portugal was helping me resolve an issue with the demo you're going to see today. So what is Uyuni? Uyuni is a very scalable systems management solution that gives you lots of choices for what you want to do for patching. One of the things I'm going to show you a little bit today of is drift control and patch cycle automation. These are features that we've been working on more recently. You can do hardware and software inventories, configuration management. We use Salt, but some people have pasted on some Ansible things, and there's a little bit of Ansible in there too if you really want to go there. And then granular control over content delivery, and this is one of the things that is most helpful. So if you've ever if you're responsible for installing Linux servers consistently across your portfolio, you may realize that if I install one and update everything today, the one I install and update everything to next week looks different from the one I just did today. And some of that's the good thing about open source is that patches come as they're available and are put into those maintenance channels, but delivering that in a disciplined patch cycle in a way that my content is controlled and given to people in ways that they can consume. This is one of the things that Uyuni is good at. And we like to say any Linux, anywhere, at any scale. How many of you manage more than 90,000 Linux servers in your environment? Okay, then you don't have to worry about scale because we have you covered. We actually have an Ohio customer who is managing 90,000 Linux servers with the downstream of Uyuni is SUSE Manager. So Uyuni is the upstream, the downstream is SUSE Manager, that's the pay for. When you get to that many, you want to have someone to lean on, right? So where did Uyuni come from? Doesn't it seem like a weird word like Uyuni, or how do you even say it? So the origin of Uyuni was the Spacewalk project. How many of you have ever used Spacewalk? Yes, the same hands. Come on, guys, really. But Spacewalk was the upstream for Red Hat Satellite 5. So it was the original upstream, and when SUSE didn't have a system management offering, we were like, well, can't we just take Spacewalk and SUSEify it and connect it to SUSE's repositories and use that as our upstream, and we would share the same upstream with Red Hat Satellite 5. So we kind of did that. That was 2010, and I've been involved in it ever since then. This project was shut down in May of 2020. So things based on Spacewalk are pretty static right now because nobody's doing anything with it. So a brief foray into the challenges of open source project management. So Satellite moved to other open source projects as its base. So Satellite 6 uses Catello, Foreman, Pulp, and a whole different infrastructure of open source projects. So as they were spinning down Satellite 5, the Spacewalk project put up on our website, we're gonna shut down May 31st, 2020. Anybody want to take it over? Obviously, we'd already been contributing. By that time, our code base was significantly ahead of Spacewalk, and they weren't accepting our upstream contributions because they were trying to shut it down. They weren't trying to make it better. So we had a meeting with them, and their brief response was negative. And so that left us with little alternative but to fork it. So we forked Spacewalk and actually added the system manager code and created Uyuni. Now, how did it get named? So this is actually a region in Bolivia that is the gateway to the largest salt flats in the world. And because we have a lot of integration with salt in SUSE Manager / Uyuni, we thought, hey, this could be a really cool name. If you want to see some great fun pictures, just look up Uyuni on the internet. They might be your next desktop background. It's that beautiful and stunning, right? So you have these reflections, and it's so flat that perspective kind of is interesting in the process. That's why Uyuni is named what it is. It is, in fact, a fork of Spacewalk, but it has lots of more features than Spacewalk had. Things that we have added, and there's more of them than even this, right? So salt is one of the key ones. So one of the limitations of Spacewalk was client communication, and we augmented that with salt, which makes it so actually that's a part of scalability for us. So by doing that, we can now scale to numbers that Spacewalk never could, and change the rapidity and frequency of that communication dramatically. Usability, there were a lot of bugs and problems in Spacewalk code. We fixed a lot of them. Plus, we've added our own stuff, including new bugs that we for a long time. We added a React Web UI, so we updated the Web UI quite a bit. But if you're familiar with Spacewalk, it can kind of feel familiar. We added a bunch of Python 3 and JDK 11 code base that was never in the original Spacewalk. And coming next is containerization. So those of you who are into digital transformation and application containerization, you'll understand that we are actually on the same journey with our Uyuni code, and you'll get to see some of it. Underneath the covers, there's one I wanted to put up here that I didn't. Apache, Tomcat, OpenJDK, PostgreSQL, Salt. We have significant teams that are making contributions to Salt all the time. Squid should be up here too, because we make significant use of that in our proxy. Prometheus and Grafana. We have a monitoring piece of Uyuni, and I'm going to show that as part of my demonstration today. And then we're using the default languages primarily of Java, Python, and Go, although there is code in that massive base that has other ugly stuff too from the past. So it's actually the upstream project for SUSE Manager, and we do upstream first. So it is ahead of where SUSE Manager is. So there's features that you'll see in my demonstration today that aren't yet delivered in SUSE Manager because it's ahead. And that gap is actually going to widen a bit because SUSE Manager has been on 4.3 for over a year now, and it will be until next June. So SUSE Manager is going to stay on 4.3. Uyuni is already wrapping in features from SUSE Manager 5, which will be delivered next year. So it's community supported, and we started this community, and initially it was mostly us contributing to it, but we have significantly improved that over time, and you're certainly welcome to be part of the community, contribute where you can. We have lots of translation things that have been contributed. The support for Debian 12 is 100% contributed by upstream and not SUSE developers. So lots of good stuff, and we're seeing some encouraging things. Once a month we have calls that are on a reasonable time zone for those of you in Ohio. So it's 10 o'clock in the morning on the last Friday of every month, Eastern time. So we target the release to be monthly. However, we don't make any lifecycle guarantees. Like many open source projects, the best laid plans often get waylaid. So the current release is 2023-04, which obviously misses the whole monthly target by quite a bit. So it's a rolling release. In other words, don't plan on any bug fixes. It's just going to get displaced the next month with a new version. So it's rolling. And you can join us here at uduni-project.org, or the GitHub site is really the place where you can see issues, and there's a wiki there along with some other documentation and stuff on the Udemy. So as we mentioned, the current release is 2023-04. However, what you will see today is actually ahead of that code. We confirmed that before we started today. But 2023-09 is coming. It's currently based on OpenSUSE Leap. So you have to install OpenSUSE Leap, and then on the website, you'll find the instructions for how you install Uyuni. That's getting ready to be dramatically widened in terms of what you can run Uyuni on, because it will only require Podman and systemd. So if you have those two things, you'll be able to run the Uyuni server, because it's just there's a couple of tools, and you'll see that. Upgrades are supported, kind of. So when you talk about support, you really mean a couple of things. One, somebody you can call. Well, you can't really call. It should work, and it's been tested. That's as far as we guarantee with Uyuni. So you should be able to upgrade it at least from the previous release of Uyuni to 2023-09 when it comes out. It will actually be taking you from OpenSUSE Leap 15.4 to OpenSUSE Leap 15.5. So just be aware of that. And again, this is the upstream for SUSE Manager, and since 2018. It's us. We are working, and what you will see today, I have 3 Uyuni servers to show you today. 2 of them are running in Podman as a single container. Now, when you think about running things in containers, you think, well, this is like really small, right? Because it's just the container, it's just got the application. But when you got a pig of an application like this thing, the container right now as it is today, 2.13 gig. Okay, so it's pretty big, right? It's not small. So what we're saying is a single dedicated host running Podman is the way that we're initially installing this thing. And the developer and I were chatting this week, and he's hoping that we'll have enough documentation and initial testing to release it to the community for you to be able to install by the end of this month. So it's coming very soon, even though Don already tried it. And it's actually working okay. So we're bringing it to containers with Podman. We chose Podman as our container runtime environment for a couple of selfish reasons. One, I'd like to say because the upstream, like Scott McCarty explained, is really hardy and super enterprise tested. We include it in SUSE's distributions, so that made it easy, right? But it's also there in the EL-based distributions. So if you run Rocky, Alma, RHEL, or Oracle Linux, all of those have Podman. And actually, I've tested running Uyuni on Rocky Linux 8, and it works fine in Podman. So, I mean, it's just Podman. So once the container is up and running, really, we have a couple of tools, and we'll talk about that in a minute. And the beauty of Podman is that it's integrated with systemd. So if you're used to running services that get started with systemd, and it's a single host running services as a service with systemd. Do you care whether it's an RPM or a container-based backend? Not yet. You will later, but we're trying to make it as easy as possible for existing community users of Uyuni to not get really ticked at us for making them learn Kubernetes yet. So this is the way we're doing it with a container runtime. We have two different tools that we're including as part of this, Uyuni ADM and Uyuni CTL. So these roughly correlate to the Kubernetes executables, but the ADM allows you then to provision standardized storage with an installer and an uninstaller. And then it also sets up the systemd services that you need to ensure that Uyuni is running properly. Then the Uyuni CTL allows you to do execution inside that containerized server. So one of the things that we want to make sure people can run things like adding channels. So in Uyuni right now, you use spacewalk common channels still to set up channels. And you can run that if you specify the username and password from the container host using Uyuni CTL space exec, and then you can run things. Another thing, if you are a customer for a SUSE manager, you'll be able to run a support config to get all the logs and everything you need to be able to get issues resolved on the server. But it allows you for CLI type execution. There are some things that are going to be outside of that will require a terminal. And like anything, you can do a podman exec and specify the instance ID and say bash and get yourself a shell in there, but we really don't want people hacking around inside of there because it's going to be complicated. But part of the promise ultimately of this will be modularization. So the initial wave is that container is a big glom of itself, right? As part of this, we've tried to pare down some of the old things that nobody needs anymore. So we're deprecating the ancient spacewalk client tools things. And that was thousands of lines of code for us to be able to remove from the server to simplify it, since we're focusing on Salt as the client communication tool. So Initial wave, we bring it as a single server, and then we start doing some modularization. The first thing to be modularized will likely be the database. So PostgreSQL right now is all integrated into that kernel. We've already done preliminary testing on external Postgres alongside of Uyuni/SUSE Manager, and it does work. There's some initial install things that right now are awkward, but we'll be enabling that later. And the goal will be to be able to have resilience and scalability, flexible scalability. And that's the promise of a Kubernetes type clustered environment. We're already delivering that for the proxy. We hope to do that in the servers. So basic Uyuni architecture, you have a single Uyuni server, and this can run as a virtual machine or in our case as a container. And then I have proxies that are essentially cached devices. So if I'm distant from my Uyuni server, I want to have my content closer so I can do my patching and provisioning and all of that from this guy who really brokers the connection back to the server, or the clients can be directly connected to the Uyuni server. In today's demo, I don't have any proxies today. Clients are connecting directly to my Uyuni server. This does not scale greatly. If you wish to scale more, proxies really help with that. So lots of features that you can use inside Uyuni, and I'm doing pretty good on time actually. So we have transparent integration with Salt from the Salt project. So as you may or may not know, the Salt project was part of SaltStack, which was then bought by VMware. So VMware actually owns the Salt project, but it has a very large community, and we have bi-weekly communication with them so that we're on the same page. And actually, it's better now. We're more aligned with upstream Salt than we were previously because we're both only delivering one major version a year now. And then there's minor versions that follow on that, and we try to consistently deliver that as a binary for all the supported clients for Uyuni. You can manage on-premises, in cloud, hybrid cloud, multi-cloud. You have all the, you can define staged content delivery for everything. You can even build OS and container images. So I have a customer who's building an ISO that that automatically installs their operating system. It defines their host name based on a bunch of parameters, including IP address, and connects through their local proxy to go back to the home thing. And they built it all with Kiwi through SUSE Manager, and they managed the versioning of that, and then subsequent scanning of that for vulnerabilities and remediation. Obviously, compliance things is one of the things that's really good at. We have a CVE audit tool, also the ability to integrate with OpenSCAP, and then monitoring, which I'll get to show you a little bit of that in the demo. Lots of things you can use. And you can manage the Linux that you need. Boy, when we talk to customers that are using the downstream of the Uyuni SUSE Manager, lots of different Linuxes that are on there. So here's an example of different kinds of Linuxes that you can use. So if you tell me, well, I look at this list and I don't see Arch, or I don't see Tumbleweed. Where's Tumbleweed in that? Well, we're trying to talk about a distribution that's going to be consistent and deployed across lots of systems. Those are really hard. Rolling releases are very difficult to do that in large numbers. But there's a bunch of distributions out here. OpenSUSE, of course, we support that. The SLES stuff, everything that is SUSE produced, we support, including SLE Micro and all the micro dev versions. So if you have micro on OpenSUSE where it has transactional update, all that's supported. All the EL flavors, all work, including the ship that is sailing off into the horizon that is CentOS 7. Ubuntu flavors of LTS. So if you have an LTS version of Ubuntu, we support that, and you'll see that in my client list. Debian 10 and 11, 12 is coming soon. It's going to be due this fall. Of course, Alma and Rocky are friends that are here and have been talking at OLF. Those guys are also supported in terms of management for SUSE Manager. So lots of Linuxes. You guys like this list? Is it good? Does anybody think we're like missing it? This makes us better people. If all I did was come to you and say, I'm just a point tool for managing SUSE's Linux offerings, this audience would be a lot smaller. But we learn a lot in this process, and we have to test and understand how all these things work from a repository management point of view, from configuration management, and you're going to get to see some of that here in a little bit. So how do you get started with Uyuni? This really long URL, you can just go to uyuni-project.org and you'll see it. But this is actually installing the Uyuni server, which will take you through the RPM-based install, where you add a repository and you install Uyuni. And it runs currently on OpenSUSE Elite 15.4. That will change before the end of this month to be 15.5, but you'll see that on the website when we release 2023-09. It's just taken a long time for us we thought we had it released in July, and we had a blocker that kept us from releasing it because we knew stuff was broken. We didn't want to break it for everybody. And then all of Europe goes on vacation in August. Seriously. Yeah. So that's why there was no 08, right? So hopefully there'll be an 09 and we'll get done. And then the containerized version, which hopefully will be by the end of this month, installs in about 15 minutes. So if you have a server with Podman and you answer a couple of questions and off you go. So it's not terribly hard to get started, and then you can start mirroring content. So the way that Uyuni works is I choose the channels that I need to support the Linuxes that I want, and then it actually mirrors that content from those repositories. It brings that content into a database where I have metadata parsed for both the binary packages and the patch metadata that correlates to CVE resolution for all of those distributions, except for Debian right now. We're not parsing Debian's security list yet. If you wish to contribute that in the Uyuni, at Uyuni, we'd be very happy to receive that. We actually had someone contribute the Ubuntu LTS one, so you'll see Ubuntu security patch metadata represented in the Uyuni server. And with that, I'm done with the crazy slides, and now you get to see a real demo, okay? So, yeah, I better hide this one. Okay, so this is the Uyuni server. So I'm going to go home here. At the start of an Uyuni server, you can customize the screen however you want. it gives you common tasks that you might do. But you'll see there's a list of my managed systems here. On this Uyuni server, I chose for today's purposes to manage a number of different distributions. So I have an Alma 9 registered client, Debian 11. I have an OpenSUSE Elite Micro, which is like a transactional update, sort of funky one. And then I have a SLES 15 SP5. This is my secondary demo server. This one's actually running on my laptop at home. This one is running in Amazon AWS. And on this one, I have SLES 15 SP4, Ubuntu 2204, Leap 15.5, Rocky 8, and a SLE Micro. So lots of different distributions, all registered and talking with SUSE Manager. Now, Uyuni. Sorry, slipped. So in your world, you would never have servers with outstanding security patches like this, would you? No, no. You keep them all updated and current. This is a demo, okay? So for this one, I might let it go for a few hours with things not being patched. But the nice thing about Uyuni is that I see that I have patches and I can remediate them. So it isn't just a vulnerability observer, it's actually a fixer. So I can fix those things if I want to. So we can schedule a patch update. So Uyuni has a scheduler that it does it can do all of those things. I've written some interesting ways for us to remediate those, and that's what we're going to look at today. So I've written a salt state. So how many of you have ever worked with salt before? Some of you? Yeah, good. Okay. So I've written a salt state here. So in Uyuni, these are under configuration channels. So I wrote this configuration channel called Update Everything. So this one, when I look at what that content is, it uses salt to do this. It issues the salt command update package. So it checks that I'm package up to date. This is actually the salt module. In my open source world, I set the no vendor change flag to be false, because a lot of times in OpenSUSE, for example, you might have repositories from the build service that say they're from the OpenSUSE build service, or they're from this project or that project. And if I leave that flag set to true, if I install it from the OpenSUSE media, it won't do it because I'm changing vendors. It will say, oh, I can't do that. But, I'm in a high-risk world. You are too. This is open source. We trust the open source world. We say false here, right? And then I refresh the channel before I do this. This is a distribution agnostic command set. So it knows when I'm a salt minion, when I'm on Debian, I use apt. When I'm on an EL-based system, 8 or newer, I use DNF. Previous to that, it uses Yum. If I'm on a SUSE system, it will use Zipper. And in Salt, I just say it this way, and it figures it out and translates it in the client with the native package management thing. And then this does a reboot if it's needed. And there's lots of distribution-specific logic that was written based on trial and error, primarily. where so if it's Red Hat, different flavors, it will check for reboots required. And SUSE is at the bottom here as the sort of catch-all. So this one was actually adopted and will appear in the next version of Uyuni as the salt state called up to date with the TO as the two. Come back. There we go. Okay. So this will update everything. It kind of comes in handy. If I want to do it one time, that's sort of easy. But what about if I want a specific time of the month? Like say the first Tuesday or first Sunday at 2 o'clock in the morning, I want this subset of my systems to all be updated and reboot them if required. So can I do that in Uyuni? Oh, yes. And I'm going to show you how. So this is kind of fun. In Uyuni, we have something that are called system groups. So a system group here is more like a tag. So if you think of the way tags are used, I can assign multiples to the same box, but they're really to help me from an administrative point of view, have some understanding of how I want to organize myself and my system. So I have a system group called Update First Sunday at 2 o'clock in the morning. That's kind of cool, right? Only right now, I don't have any systems that are part of it. So I might choose some systems to be part of it. I can do it a couple of different ways. If I open this group and say target system, it will show me all the systems that aren't yet members of this. And then I can just sort of randomly select them. So I can actually do all of them because the first Sunday at 2 a.m. we will never see as part of this demo. So that's okay. So I can select them all and say, add the system. So now all of those systems are going to get updated on the first Sunday at 2 a.m. But what does that schedule actually look like? So this is a very new tab. So those of you who have used SUSE Manager or Uni before, you've not seen this yet. So we have what's called recurring actions. And they can be a high state, which applies all the states, or it can be a custom state, which is what this one is. So let's take a deeper look at what this does. So I give it a name, a schedule name, that I update every first Sunday at 2 a.m. and reboot if needed. So, I mean, it's like real English language thing. I can select a schedule of my choosing. If I don't like the schedule that's offered to me with this templated thing, I can use a custom quartz format. And in this one, because it's squished there, you can't see all of it, but this is 002?1/1 sun pound 1, right? So any quartz format, if you go out there, there's quartz formatters on the internet, it can consume this. So it will be every first Sunday at 2 o'clock in the morning. And then I configure a state to execute at that time. So I can choose this up to date, which is the one that is native to SUSE Manager. That's the reason why it's black. Or I can pick the one that I wrote and showed to you, update everything, and just choose that one. And I can unselect this one and say save changes and confirm. When you put multiple states in here, you can rank their execution order. So if they're touching the same file, one will win, right? So I only have one state, so I can confirm it here and update my schedule. So now it will happen, this custom state will happen at that particular schedule. So that way now my patch cycle is now automated for me. I just have to make sure my systems are assigned the right channels and they get the content they're supposed to get, right? So, so that's patch cycle automation 101 with SUSE, with Uyuni. So I'm going to actually go to one of these systems, and we'll run it now. This one, let's see. Do I want to do the Rocky one? We'll do this one. So this is a SLE Micro, and I'm going to assign it differently. This is a one-time execution. I can pick my update everything, assign it to this box, and instead of it being recurring, I have to manually click here to execute, and this is included, right? So I clicked on execution, so it's already going to run, and it's scheduled and running, and I'm not so, you can see now it's already gone off the server and offloaded out to that Salt remote execute. So it's actually happening out on the boxes. So I can concurrently schedule all these things, and it's not dependent on my own server to hold up the sequential scheduling for everything. So now I'm going to show you part 2 of this demo that should be really fun, right? So since I have this flexibility of schedule, how about if I do something different? So I have a configuration management channel. Let me make this bigger again here, because I'm over 50 and my eyes are terrible. Actually, I'm over 60, so don't tell anybody. But I have this Apache server salt state, and this one has lots of customization for different distributions, but essentially what it does is this. It installs Apache, okay? I don't care whether you're Red Hat or SUSE-based or Ubuntu. Then it makes sure that the Apache service is running. It shuts off the firewall, and it installs a customized index.html file in the right place. Okay, so I have a standardized index.html that delivers, it turns these boxes into web servers. Now, this is kind of cool on a one-time basis, but what if I have one of you guys with SSH access into one of these servers? You are dangerous because you know how to stop services, and you know how to edit files, and you know how to install and uninstall packages, and maybe you're going to bust it, right? So what I want to do is create some kind of drift control to prevent this from you screwing it up, right? So here's how Uyuni can help you to do that. So I'm going to use the same kind of a tool where I have a system group. So in my system groups, okay, come on, Don. Here we go. System groups, I have Apache web servers. And right now, for systems, I have one server that's already a member of it. It happens to be running Leap 15.5. So I'm going to add the other systems that I want to become web servers. So I'm going to add everything except for the SLE Micro box. SLE Micro doesn't include Apache in its distribution, so it can't be an Apache server, so we're not going to include that one. But I'm going to add these systems, so then all 4 of them will become web servers. So let me show you what happens when you do that. So I made this schedule for Apache web servers. Again, I'm using the recurring actions feature, assigning the web server state, and I named the schedule drift control for Apache web servers, and it's set to run every 15 minutes. So every 15 minutes, it's checking all those things. Is it installed? Is the service running? Is the firewall off? Is the index.html correct? and it runs on that box, and we'll fix it and change it. So I'm gonna show you the event log from one of my servers that has been running this for quite a while. So this Leap 1551, I made a member of this group quite a long time ago, so I can look at the event history. And Uyuni is really good about keeping an event history of everything that has happened on this box and who scheduled it. So right now I have only one user, admin, and admin is the bad guy responsible for scheduling this. But you can see that it's been happening actually every 15 minutes. It's been happening on this box since earlier this afternoon. So if I go down, let's see. Yeah, here's the first one that happened at 11:30 this morning. So the first time that it ran, you can see it's installing all the dependent packages for the Apache. It sets the Apache service to be running, and it enables it so that it persists through a reboot. And then it makes sure the firewall is off. The black one means that it actually didn't have to take any action because the service firewall deep was already dead. And then it added this standard index.html. So if I go to this web server, so let's see, which one of these is that one? I think it's, so let me bring over my web browser. This is a live demo, so, and this is the first time I've ever shown this one, so that's kind of cool, right? So you can see this is not running right now because these are some of the servers that I haven't provisioned, but this is in fact my the very real demonstration of my complete HTML coding skill. Right, that's it. One line, sorry. But this one has been already updated on that server. So the other two, which were dead earlier today, let's see if they're already running. So this is a risk, right? It's not done yet. It's not done yet. But you can see this is what happens when you do a live demo. You don't plan it greatly. But by doing this now, no matter which part of that thing somebody breaks, it's going to remediate itself and be drift controlled every 15 minutes. Okay, so with that, I'm going to go back to our slide deck and just conclude. So what questions do you guys have about Uyuni today? Anybody? Yeah.
So I'm naive because I've never heard you before the salt back. I'm assuming that event history, it's being logged somehow. What's the facility for that?
Yeah, so good question. It was about event history. So everything is logged in the PostgreSQL database. So there's actually two different PostgreSQL databases. So you have the live one that contains all the actionable items and things like what happened with the system. And then there is the reporting database, which every evening exports that stuff so it's queryable. So then you can attach a SQL query tool to it. We have a number of stock reports that read out of that reporting database. So you can get complete inventory. You can do applied errata, system history, a lot of those things. But PostgreSQL is the magics behind most of what you see on that screen is stored in the PostgreSQL database. Okay.
So maybe think of another. So where is the PostgreSQL running? Is it running external as a second one?
No, right now it is in, so the question is, yeah, so the question is, Whereas PostgreSQL, and for a number of years, we've only supported the embedded PostgreSQL, which we have tuning parameters around that both for the stock one and some extra tuning things if you want to do that later. But we also are in the process of modularizing that. So we have a certain requirement, obviously, for schema introduction, that we don't want PostgreSQL to be, okay, I'm going to run PostgreSQL 12. Well, we wrote everything based on 14 or whatever our current version. So there's going to be some version requirements, and then there'll be special instructions on ensuring that schema updates occur properly on that external database. So second question.
And then, how do you get push and pull machines under this environment?
Okay, good question. So the question is, how do you onboard systems, right? There's actually 3 different ways to onboard the systems. One is you can pre-install a Salt minion, either the bundled one that we provide or one that may be included in the distribution, and then add your own configuration to point it to SUSE Manager as the master and tell it what activation key to use to register. That's sort of manual, but you can build it into that, and in some distributions that makes the most sense. The second way that you can do it, in the web interface, there is actually an onboarding tool, but it means that it has to be SSH reachable from the SUSE Manager server to that box. And that may not be the case depending on how your network rules are written. The third way is the preferred way, and that's with a Bootstrap script. So we give a templated Bootstrap script with a number of options that allows you to onboard at a much larger scale, and it does customize things like under the covers, it's detecting, okay, are you RHEL or are you SLES? Do you need Yum or Zipper, to install the client? And we use a small Bootstrap repository, also automatically generated into the Uni server. So each time you do a channel synchronization, like I did for all these systems for Ubuntu and Debian, the binary package we deliver currently is a salt bundle, a unified salt bundle that includes the necessary Python libraries for that salt minion to be effective. So then it turns it on, tells it what server to point to, and registers the box back with SUSE Manager. So that's how typically onboarding occurs.
So if you have an existing salt stack environment, can you add the server as a multi-master setup?
Okay, so the question is a good one. If you already have an existing salt environment, can you add the Uyuni server as another master? We did some significant work. In fact, one of my good friends who's a salt developer did the bulk of the work of this. He lives in Barcelona now. But we created a separate salt minion that is a contained one called venv salt minion. It uses a separate configuration file from regular salt minion, and it enables you to have a separate infrastructure for that. If that isn't what you desire, there are other ways that we have our services and a consulting organization on the SUSE side has worked with integrating top SLS files. So that multi-master thing is challenging, but if you abide by certain structures, it can work there. Otherwise, you can do them separately. And clearly, if you're doing salt already, you just caveat is don't try to manage the same file with 2 different salt master infrastructures. You're going to drive yourself crazy. But it's certainly possible to be done. Thank you.
I'll do one more.
Yeah.
On the scripting, is it possible to, if do an update, send shut down a process, look to see if that process is shut down, like a timing loop, and then if it doesn't, issue a kill command or something like that to kill the process?
Yeah, I'm pretty sure there almost any of those things. Now, the most difficult thing within a particular salt state to happen is a reboot action. So the manager can, or and Uni can get around that by using what's called action chains. So you can create a salt state application and then inject a reboot and then do another salt state after, and it will do it sequentially, scheduled from the server to call those kind of things. But outside of reboot, almost everything else is scriptable. Okay, yes.
Making this run in a container really exciting for your long-term plans to be able to run this on the Kubernetes.
Okay, so the question is our long-term plan to run it in Kubernetes? Yes, and much, did you tell him to ask that? He's wearing a rancher shirt, so I have great suspicion. Yeah, the goal long-term is to be able to do that. This is complicated, and we have a lot of customers and a lot of Uni users that want to keep continuity. So we're trying to do it in a measured way to get there. And this is the first step of that. But ultimately, we'd like the promise of Kubernetes for that resilience and modular scalability that are the promise of that environment. And we'd absolutely like to have Rancher just say, launch SUSE Manager. That would be super cool.
Lifetime's not a full hour, so if you got any more questions you want to wrap up on, please. Anyone else? No one? No one?
Thank you so much for your attention today. I hope you enjoyed it. What's so funny? Does this run on Kubernetes today? Probably not. Everything works, so.
Hi, everyone. I'm going to give you a little bit of behind the scenes of our operations here at the open source solution stage. I've got a microphone that is plugged into over here, which is using, let's see, trying to use as much free software as possible to make it all work for everyone. Hey, look! You can see myself. Is it really the same thing all the way down? Okay, well, you never know. Thank you so much for tuning in to the open source solution stage. Next up is our final talk. Robert Sciatra will be talking about SUSE containers as soon as he gets set up here. If you want some of the real live conference experience here, I'm going to hand over to Robert.
For the scrapes, and then it will just deploy the config. You have a manager.
There he is. Robert is the SUSE community manager, and would you know it, that he lives right here in Columbus, Ohio. He's about to tell us all we need to know, or wanted to know, or have to know about SUSE containers.
And then it pulls those down and channels them.
Move over to where we have the page for the open source solution stage. Yes, fantastic. Let me read this for the record to all of you, current and future watchers on the internet. We just had Don Glasper come to our open source solution stage. So a product manager for SUSE, focused on management solutions. Don Glasper has been a long time speaker here at OLF, and Robert Sciaccia is back for his third year in a row. We are very impressed to have him here in part of our OLF community. He's going to be talking about diving in with Linux enterprise-based container images. We'll take a deep dive into new base container images from SUSE based on SUSE Linux Enterprise Server. We will go through some of the more common cases for containers, go through the different types we've created and can create for your own base of SLEBCI. Oh, it looks like he does have his slide deck up and running. So let's go ahead and cut over and take a peek. He says that he's got over an hour worth of content, and he's running 3 minutes over time. No drama here. No drama. Ding 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 ding. Maybe our first or second speaker of the day was correct. When all you have to do is say howdy to get everyone's attention. Or I could just stand up right now and do it. Hi everybody! Who's here to hear about SUSE containers? Why are you chasing me out, brothers? You can't escape. You owe us a talk.
But when Don, you guys don't work with Don like I do. Like if you let him keep talking, he'll never leave. All right, are we ready to get Beth? Are we ready?
Yes, we are ready.
I know I am at the end of the day, so before we get started, I'm not going to go the full hour. I'm going to save you guys. I know there's a party afterwards. Yeah, clapping back there. I was putting this together. My wife goes, "What is the presentation?" I'm like, "The last one." She goes, "Don't go the full hour. Don't go the full hour." So we're going to be doing a deep dive into SLEBCI, and if you don't know what SLEBCI is, I will be talking to that. Here's our agenda: an introduction. What is SLEBCI? The types of BCIs that we have. We have our general purpose, language specific, application ready, and then we'll go through a couple use cases with it. There was a talk earlier about Docker and accelerating your developer workflow or something earlier. I wasn't part of it. I missed it, unfortunately. I had booth duty, but I'll kind of compliment what that was about. And then some final thoughts and next steps. So my name is Robert Serchia. I am the head of community evangelism at SUSE. What does that mean? My job is to talk about our products and our projects, get people excited about them. I'm not a salesperson, I'm not a pre-sales person. I just get to go talk about that. I have a .NET background, grew up here in Ohio, and I've been writing code for 20-some years about that. So what is SLEBCI? SLEBCI stands for SUSE Linux Enterprise Base Container Image, right? And a base container is a container that's, well, it's kind of the foundation of anything else that we put out there. But we built one that's based on our SUSE Linux Enterprise, right? The same SUSE Linux Enterprise that we sell. And it's the binary compatible to our Leap OpenSUSE version of Leap, which is another operating system that's out there. So why did we do it? Well, we wanted to give you guys the ability to create customized container images based on Sleep, right? And I'll get down to like why I like this project, because in my previous life, the problem this is solving burned me earlier in my career. It's available for Arch 64, x86, PowerPC, and X390X. Stability, I said this earlier, this is all based on SLE Linux, right? So it's just a Linux enterprise, and it's binary compatible bit for bit all the way up. And so that's part of what makes this pretty awesome and amazing, is that it's based on our hardened Linux enterprise version out there. We talked about security, but it's already there. We have, we're third parties signed, and we have SALSA level 2. I think it's level 2. Don't quote me on that one. I will get back to you on that. And then our free redistribution. This one here was interesting because I did not know they did this, because I don't know how many people read the EULA, like when you update your phone. Anyone?
No.
I don't. I didn't know this, so this is, when they told me about this, it's kind of interesting. We really don't care how you redistribute it, right? We don't. Like if you want to use it and put on Gigabyte or something like that, I say Gigabyte because I have a lot of friends who work there. We don't care, right? And you want to like post it out there that is free. We are very open. We encourage people to do just that. And by the way, if you guys have questions as we're going, I'm okay if you guys interrupt. So types of base container images. We break it down into 3 different conceptualization types that we have for it. The first one being general purpose. Next one will be language specific, and then application ready. Okay. So general purpose, we have 4 base container images that we support. First one, BCI init, I'll go to that in a minute. BCI base, BCI minimal, BCI micro, and BCI busybox. I'm not gonna lie, the use case on busybox is just very, very, very small, but you'll see in the diagram that these actually get smaller in size, and that's intentional, right? We actually narrow it down we want you to pick the right base container image for your use case. You don't need to always take the BCI init because it might not work for you. But you're probably wondering what the heck the BCI init is. Well, it's about 150, 160 megs. It has systemd and zipper installed and can be used for a whole system-wide container, right? So this is kind of like the default base. I see a lot of people using this one here, building something that is going to run as a container on top of Linux, doing something that goes a little deeper than some other use cases, right? I would not use this if I was deploying my application in Kubernetes. It is way too big. It's not optimized for it, but we have it there for it. Now, as you get down the list, and that reverse, I guess I should have kind of like reversed it and made it like kind of a pyramid. But in our reverse pyramid here, we have our BCI base. And this one is, when we talk about dev containers, I'll talk about them a little bit later, this is the perfect one for it because it gives you the ability to install things. Now, if anyone who's used SUSE Linux, Zipper is how we install our packages. I had a hard time with it at first, love it now, but when you need something else installed into your container for development, right? So if you're making a dev container, you're like, what do I need in there? I don't know, and you're playing around with it, you can use this one. This one is very flexible, a little bit smaller, but it doesn't have systemd installed because you probably don't need it. Did I go too far? No. All right. BCI minimal. Now, this is an approximate file size of 48 megs. The one I had at home on my other machine was 43, so it's going back and forth depending on the build. Zipper is removed, but it does have RPM package manager installed in case you need it, and this is perfect for creating deployments of containers that you would use in Kubernetes, right? This is usually my default. So if I'm building an application and I'm gonna bundle everything out that I might need and I gotta throw it out the door, that's the one I usually kind of might go to, right? So when I was talking about that dev container, It's usually this one, and between these two is where I'm deploying my applications. But because I know it's all based on a base container image, it's not, I'm not worried about it not working. If it doesn't work, it's just because it's looking for something it doesn't have. But if your application is looking for RPM or zipper, doing some weird things I don't know about. And then this is BCI Micro. Great for multi-build artifacts that you might have. You want to build everything, attach it to, or append it to this, and then deploy it. So the binaries have to be produced externally. You cannot do it internally, it just doesn't work. This is for lighter workloads. This is what we see in our edge instances. So if you're running K3S on a Raspberry Pi and you're deploying an application, you're probably going to be using Sleep Micro for that. And it's great for the edge, but it's also something that we'll see in some use cases in Kubernetes where we want individuals to like strip out even less than before. We don't need those the RPM package manager. BusyBox is primarily for the automotive industry. It's where we've seen most of our use cases. I don't personally use it, but if you need it, it's there. What I have used it for is when I'm testing Kubernetes and I'm testing deployments, I usually deploy this container itself. Language-based. With Sleep BCI, we support the latest version. I think we go back a version, maybe 2 for most of the popular languages out there. Rust, .NET Core. I still say .NET Core because we cannot do .NET Framework. I want to make sure I say that so no one knows. Python, Ruby, Node.js code, and Java. Now we also support runtime versus development, right? So you'll have, for .NET, we have the .NET 7, .NET SDK. For development, and on the other side, we'll have the runtime when you're building up your applications and setting out the door. The size difference is pretty significant between the two, and then development has things in there that you probably don't want to ship with your application, just for security reasons as well. Application ready. This is where as this is a newer project here at SUSE, this is where we're working with partners to bring more applications to our portfolio of within SUSE. Not only within the traditional SUSE Linux side of the house, but within the Rancher side. So if everyone knows SUSE, we have kind of like 2 sides of the house. A third if you count our edge unit. But we have containerizations with Kubernetes managed by Rancher, and then on the other side we have Linux. We all play nicely, but we're pushing more and more of our partners for images that are application ready. Right now, we have a few of them. We have Nginx, PostgreSQLs, OCI Container Registry, and Performance Copilot, and coming up. And we're working with partners right now to expand this catalog to more databases, more ancillary services. But if you have one, we don't prevent you from doing it. We have the tooling to do that, and we encourage people to do that. Now we have IBS and OBS, which are IBS is not irritable bowel syndrome, so I want to make sure people know that. It's just like when I was practicing this at home, that's what my wife thought. IBS is our internal build service. OBS is our open build service, where you can build these containers for that. So if you say you're out there and you're like using MongoDB, but we would like to use SLE underneath, we give you the tools and the ability to do so, and you can add to this. You have a registry for that, but we're working with partners directly so we can have support back and forth. But if you needed one today and there wasn't one, you can do that. It's part of the tooling we have. So using Sleep BCI. Well, there's a couple of use cases, but the most important one that I like to talk about is the one that we see mostly is, well, building our images, right? And we can do this all from a Docker command to just do that. Now, there's Container D, there's Docker. Nerd CTL will allow you to build both, but if you're doing something with System D, you're probably going to need Podman or Docker over using Container D. Container D, you'll see more on the ranching side. But from this, we can pull our registry, right? And talked about this earlier. I'm just using the SDK for that, right? Pull it down. I create a working directory, I copy, restore all of my files that I need into that particular container working directory. .NET command, I forget. This is basically publishing your code. It's like building it, but it strips out all the PDB files and all the debug files. And then we put it into an out directory. And then from there, we pull our runtime, which is our ASP.NET 7.0 working directory. And then we copy all that in there from the build environment, which is I specified here. I want to tell it to expose port 80 and then give it an entry point and the hello world DLL. And that's all you need. Your application is going to run. You can deploy it from there. This is the most common use case that we were seeing people use with it, right? Pull my application or grab an SDK container. It's latest and greatest from the registry. It's secured. I don't need to worry about it. Nothing malicious is going to be there. I do a restore, pull my application, my code in, I publish it, I build it all up, I send it out the door. Easy as can be. Questions so far?
Would you rather than at the end?
Right now, I can break it up. See, I like it. See, the problem is, I go at the end, people are like, I had that question. Where is it?
I'll ask one now then. So it's, like you mentioned, you don't have to worry about it because it's been security hardened to some extent. What standards are you determining that against?
I would have to actually defer you back to the SLED documentation for that. So it's everything, and that's the value out of it. So we're using the same binaries that we use for SLED. If you ask me to memorize those, I don't think any of our engineers on this side have that memorized. Like, I know there's a sales guy from the back there, you probably like, I can share that information, but I don't have it memorized. But yes, I know we have salsa, I believe it's level 2, don't quote me on that one. But everything that we do, binary all the way through is for that. And the reason why we have that, and I'll talk about it towards the end, is for support later on, right? And so that's why it kind of matters. So development in VS Code, and I have a little demo I can show with this. This right here is where I'm seeing a lot of it, and I've helped a few customers with this. I've helped quite a few community members with this. I don't normally talk to customers, but sometimes customers come into the community and ask me questions, but they're doing the development work within the container. I think I don't want to denigrate from the talk that talked about it earlier, but we're seeing a lot more of this, and where the developers are saying, hey, I got to get ramped up, I got to get started. What is everything I have to do to my machine? They're using the development containers, and I'll kind of show what this looks like with CBCI because they're deploying their applications directly to Sleep. And so that's all their environment. Everything is there. They're writing Go applications for it, and they're just publishing it through. And from there, they can take those binaries and test them and go for it. So they're already there for it. We're also seeing that same setup they're doing with .NET. We're seeing it with OpenJDK, which we support. And Ruby, I haven't seen Node yet come through the community yet, but this is the way they're doing it. So some final thoughts. This is fully open source. Everything's out there. You can go to OBS, you can see how it's built, you can see how it's configured out there. I don't remember the URL off the top of my head for OBS, it's linked on my browser. But everything for the CBCIs is in our OBS, not our internal build service, so it's all exposed out there. Everything's out there on GitHub as well. You can go out there and you can see the code. You can have questions, you can ask it obviously on GitHub things. It's easy to get started. We have documentation for it, and it's easy to redistribute, right? We don't care where you're going to put it. I think we might care, like a missile or something. Someone might have it, but if you're doing that, you're probably not gonna be sitting here right now. But it's very easy to redistribute, right? If you're building something, you want someone else to use it, you're building something, you wanna send it to a customer, we don't care. In fact, that's our, EULA allows us to do it. And if you need support, you can get it without recertification. Now, I said earlier that this burned me earlier in my career. I built an application, .NET application, .NET Core, and we used lots of containers. And we're through dev, we're working, everything's like, when we pass QA, we're excited, we go flip the switch to go to production, we flip it, and then security and compliance came back and said, hey, those container images are not scanned, and they're not compliant. So we had to stop, roll everything back, get the compliant ones, and then start over again. This kind of gives you, this kind of stops it. Now, this is the same model that you see us use with our OpenSUSE Leap. It's binary compatible with Sleep. It's actually like a 3-minute flip up. So it gives you the same workflow and the same like look and feel when you build something. You got that POC for your boss. And you're like, hey, this prototype, this can work and this can solve it. I didn't use any extra licenses, nothing like that. And he goes, I need support to it, and it's a flip of the switch. We have the same mechanisms. So I'm going to try to do my demo here, but some next steps I want to talk about. And I'll make sure these links are available. I'm not sure how other projects are, but GitHub Stars is the currency we actually operate in. Hold on, hey Beth, can I give you my slides in the PDF to distribute?
No, you did not.
Sorry.
You can make that right, man.
Well, maybe after this.
Yeah, sure.
Okay. The link for GitHub right there to give us a start. That's our currency. That's how we know we're doing good in the ecosystem. That's how we know we're doing good in the community. We actually like that. We have redone the docs. Actually, I was writing some of the docs, and you can see some of my grammar in there. We have some examples. I'll show you some of those examples here. We also will show how to go deeper with some of those those nuances between BCI micro and BCI minimal, right? Linked to those particular use cases. And the only thing I don't have in there for that is when you should use what base container image for what. We have a registry, and I'll bring up that registry here in a moment. So I want to show you how easy it is to go pull that, give you the documentation for that. And then I talked about this earlier, GitHub discussions. So this is a kind of a departure from how we do things differently. We're using, on this project, we're using GitHub discussions. So if you find a bug, you have a request, you want to tell us how awesome something is, we're going to use GitHub discussions. We haven't unified across SUSE, so sometimes we use forums, sometimes we use this, sometimes we use our Slack channel. For this project, the link is there. I will make these this slide deck PDF available so you guys can see what that looks like. Questions? Okay. So we talked about it. This site here is opensource.suse.com/BCIs. Kind of our landing page for all of this. It has a link to everything that you might need and you question from the registry to the docs. I want to go to the registry real quick. Standardsuse.com. These are all available for download. You can find one. Talk about the BusyBox. We have the latest, and this one's going back quite a few versions, surprisingly. And I've asked what we're going to support version back, and I don't think they've decided how far they're going to go back for the level of support and how many versions that we're going to keep out here. But with either Podman or Docker, we'll tell you how to pull it, tell you how to operate it. These are the same open source, it's the same as the supported ones. It's not like two different places you're pulling from. Here's here. So when I sent out the my PDF, the dev containers we talked about, same thing. If you're using VS Code, I'm not going to get into war whether VS Code is better than Vim or Nano or Emacs, but in here it gives you the ability to do that. with this little file that you have, you give, and this is probably talked about before, I'm using the registry.net SDK 7.0. I have a handful of extensions in here, and with one simple click here at the bottom of the status bar, I can re-open the container, give it a second, and you know you're working within the container. Okay. You know how this works. Say you do a demo, it just takes forever. Mind you, I built this demo on this machine. And so when you guys are like, why is it taking so long? When you know you're inside the container, it gives you the container ID. It'll tell you its workspace in the BCI. You're in there, you're working, and you can do any command that you need to do it. You can make sure, and you can do any type of pre-release commands that you might need. Change directory. You can actually publish all your code in there. And you're working everything within the container. Now, in the diagram before, you can mirror the your code repository in and outside the container. It helps a little bit with the I/O, but it's just working just like normal. Now, if we want to exit this, it's just as easy. You can close remote connection. This is what I don't like. It goes, hey, I don't know where you're at. And you kind of reopen it. Now this is back on my machine, and it'll prompt you for what that looks like. And if we want to, thank you. And if we want to build that same Docker image, we can build it here. Now I'm using this example, building it out, because we built it once within the container, right? As a developer working, I'm building it, I can test it, I can run it. It exposes a port, I can test my web application or whatever I might be. And then this is an example of this running externally, which would be in your build pipeline. And it is using the so-called Docker file that I showed you earlier. Same one here, nothing exciting, nothing great, but it built that and that can be deployed and it will give you a basic .NET web application that it might be, and it works. So that is my presentation. I kept it about 30 minutes. So I know there's a party afterwards. I can't wait to see everyone else there. Questions, comments, concerns? Nobody. No happening? You can have it. It's okay.
Do y'all have 32-bit builds of any of these images?
Right now it's 64, but it's a good question to ask if you. Is there a particular use case that you're looking
I was
for?
thinking in my head, I was thinking about certain containers, like Happy Pies and stuff like that.
It is obviously I'll give you guys a thing for the discussions. It's something to put there because it puts it on our radar and we see more and more of it. We're looking to carve off bigger pieces for bigger use cases first. So it's not saying we wouldn't get to it. It's like they're looking at, can I get RavenDB out here? What does that look like? Anything else? Okay. Well, I'll see every one of you guys afterwards in our after show party, and I will give Beth these slide decks. Thank you.
Okay, wonderful. Thank you.
Oh, and before I forget, please, I don't want to take these home because I don't want to be forced later. Anyone? Sure. I'm not throwing them. I write code. I don't play sports.
At year 2, there was a Susie guy, or actually they came in trios, who would throw geckos everywhere.
No way. I know my limitations.
And you had to ask a good question, which was so subjective.
I'm giving you all.
But yeah. I'll definitely take one home for my boy. My boy is a plushy boy. Thank you.
So are we recording all the conferences or is it just live stream?
And this is live stream, which records on YouTube.
Okay, great. So
Would you like to be on camera? Would you like me to be on camera? We're about ready to sign off for the day so that we can all join the general stream. And that will be awesome. Very awesome indeed. Hey, did you chip in for the raffle yet? Do you know about the raffle?
I do know about the raffle, yes.
Did you chip in for the raffle yet?
I tried to use the site and it wouldn't take my email and it forces logins in order to participate in the raffles.
Oh my.
Yeah, which is a little unfortunate because that's a really interesting 3D printer.
Yeah.
But that's okay.
Yeah. It's an interface that empowers you to go ahead and participate in a raffle online, and that's something that I introduced whenever we were going hybrid.
Sure.
Because I wanted to have it as an inclusive of a hybrid experience as possible.
Yeah, no, it's
And that's why I'm actually including this type of content, like the conversation we're having right now, to make it be something that people will be able to capture and enjoy for not only the live stream, but for years to come.
Yeah, that's good.
Luke, when you'll be watching this, mommy scored you this fun gecko. I know that you're gonna like it because there is a gecko on your school Chromebook. Yes, there is. I know.
So I have some blue microphones at home, and if I remember correctly, this particular model is not completely omnidirectional, but it does try and look in a plane that's perpendicular to the base.
Yeah. Let's talk about that.
So this, it's better functioning like that.
Okay.
If you can tighten it.
Oh yeah. Definitely give me those types of tips about it. I take them to it's a local municipality.
Sure.
Government meetings, and nobody has any amplification at all, and it's a room about half of this size.
Yeah, well, it's good. It's already in the right pattern setting, the radial instead of the cardioid, but it does function best when you're speaking into it from that direction instead of the top. That's about it.
Okay.
Yeah.
All right. Yeah. That's good to know. So I did go for the introductory model because I wasn't sure if it was something that I was going to like. I like it. Is any other model worth it? And I know that this camera is extremely low grade.
I mean, it's decent.
But you got to understand that what I'm capturing there doesn't include any slide decks, and it includes just making sure that you can prove that you are where you say that you are, and the person who is speaking is really speaking, and that's it. But the audio is what is most important, and I figured, well, this is a scenario also where the audio is most important.
Yeah.
Because you can certainly say, well, here's the slide deck later, but you can't really capture everything that was actually said unless you record it.
Yeah. Well, I agree. And the Yeti Nano is a good model. It's good value for the money. I definitely like the full-size Yeti personally. I think Rode makes better microphones than Blue does, especially if you want something that's directional instead of omnidirectional.
I really need it omnidirectional because
right, exactly.
like some government we'll have like a podium for you to go up to make your citizens comments. No, there's no space in this particular room, so you just have to stand up where you are and speak.
Yeah, that makes sense. Yeah.
Mhm.
So that's probably the Yeti's probably best for that because it's a very good omnidirectional mic.
Yes.
But if you and Rode makes some good omnidirectionals too, but they're a little more pricey. Yeah, that's a good choice.
Yeah. If I was to consider upping my game regarding the camera, it's really good to not have much of a power dependence on this device.
That's just straight on the 5-volt USB. It's great.
And but like there's no Zoom about it though. This is what you get.
Yeah, that makes sense. That's sufficient for this use case, I think.
And well, the use case back at the municipal government, there would be perhaps some issues if the tripod could even stand a little taller because then it'd be a situation. Well, I can't see a camera. So yeah, yep.
That's funny. Well, yeah, I think you're doing well.
Yep. So that's what it is, and I'm in it for open government and open source.
Well, yeah, that's cool.
All right,
Appreciate
fantastic.
it. Oh, let's go.
All right, take care. All right, yeah. You enjoyed the open source solutions stage all day here with me at OLF conference. I hope that you can join us again next year. I hope that you can join us back at the main stage, back at the OLF conference live stream. And if you're watching this in the future, hi future. Goodbye.
Well, that's the thing is,